The integumentary system, though often overlooked in comparison to the heart that beats or the lungs that draw breath, is a quiet guardian that surrounds us at every moment of life. It is the first point of contact between the body and the world, a shield that does not rest, a living covering that grows with us, adapts with us, and even silently speaks on behalf of our health. To begin this slow and calming journey into its depths, imagine the soft sensation of a breeze brushing against your arm, or the subtle warmth of sunlight on your face. These are not just fleeting experiences, but reminders of how this system allows us to perceive, to adjust, and to remain in harmony with our surroundings. When we pause to think of the body, our minds often wander toward the beating of the heart, the workings of the brain, or the movement of muscles and bones. Yet the integumentary system quietly does its work with equal importance. It is composed of the skin, hair, nails, and the delicate glands that serve many functions, each part seamlessly woven into the whole. Together, they provide protection, regulation, and sensation, all while maintaining an elegant balance between the inner and outer worlds. The skin alone, the most visible aspect of this system, is astonishing in its scale. It is the largest organ of the human body, stretching unbroken over the entire surface, amounting to about 16% of body weight, and covering close to 2 square meters in the average adult. And yet, for all its size and importance, it is so often taken for granted. Imagine standing outside on a summer's day. The sun radiates warmth, and the skin responds without your conscious effort. Tiny sweat glands release a clear, cooling fluid, and as that fluid evaporates, heat is carried away from the body. Blood vessels gently expand beneath the surface, allowing warmth to dissipate into the air. In the same way, on a winter morning, when the air bites cold, the skin responds again, this time conserving heat. Blood vessels narrow, drawing warmth closer to the core, and tiny muscles at the base of each hair contract, raising them in the familiar pattern of goosebumps. These quiet responses, happening ceaselessly without thought, are testaments to the wisdom of this system, which regulates our inner world against the shifting conditions of the outer one. The integumentary system is also a storyteller. It records the years in fine lines and wrinkles, marks the passing of time with freckles and sunspots, and bears the small scars that remind us of the body's ability to heal. Skin tones, textures, and the condition of nails and hair often speak silently about health, vitality, or imbalance. A sudden pallor may hint at reduced blood flow. A flushed hue may reflect exertion, warmth, or emotion. A yellow tint can point toward issues of the liver, while a bluish shade may reveal low oxygen levels. Even the nails, though small and often overlooked, may show signs of nutritional deficiencies, disease, or stress within the body. In these ways, the integumentary system not only protects us but also communicates constantly. If we learn to read its messages at the microscopic level, this system is in a constant cycle of renewal. The outermost layer of the skin, called the epidermis, is made up of cells that gradually rise from deeper layers, flatten, and harden with a protein known as keratin, before finally being shed into the environment. This process takes place continuously, meaning that the skin you see today is not the same as the skin you saw a few weeks ago. It is always new, always regenerating, always protecting with fresh layers. Beneath the epidermis lies the dermis, thicker and richer, filled with connective tissue, blood vessels, lymphatic channels, and nerves. Within the dermis, sweat glands and oil glands perform their essential functions, and the roots of hair follicles take hold. Even deeper still lies the hypodermis, a layer of fat and connective tissue that cushions the body, stores energy, and insulates against the cold. Each layer, though distinct, is intimately connected, forming one unified whole. The integumentary system is also an instrument of sensation. Within its layers are an abundance of sensory receptors, tiny nerve endings specialized to detect touch, pressure, vibration, temperature, and pain. These receptors allow you to feel the softness of fabric, the sharpness of a pin, the warmth of a fire, or the coolness of a breeze. Some receptors are so finely tuned that they can detect the faint movement of a single hair on the skin, alerting you instantly to the lightest contact. Others respond only to deeper pressures or to extremes of temperature. Together, they form a vast network that conveys information to the brain, helping you navigate the physical world with safety and awareness, even when you are unaware of the constant flow of signals. And yet, the integumentary system is not only about defense, regulation, or sensation. It is also about connection to the natural world. Through the skin, in the presence of sunlight, the body synthesizes vitamin D, a substance vital for the health of bones and the regulation of many other processes. In this way, the skin links us directly to the sun itself, quietly converting light into nourishment. Through hair, eyelashes, and eyebrows, it provides protection to sensitive organs like the eyes. Through nails, it offers strength and defense to delicate fingertips and toes, tools we use constantly in daily life. The oil produced by sebaceous glands prevents dryness, maintaining suppleness, while sweat not only cools the body but also assists in excretion of waste substances. Perhaps one of the most extraordinary qualities of this system is its ability to heal. A small cut, though at first alarming, sets in motion a cascade of processes. Platelets in the blood quickly form a clot, creating a protective barrier. Beneath this, new cells divide and grow, weaving fresh tissue to close the wound. Over time, the skin restores itself, often leaving behind only the faintest trace, a reminder of the body's resilience. This power of repair, this ability to restore integrity even after damage, speaks of a system that is not only protective, but regenerative, designed with both strength and grace. The integumentary system, then, is not a simple surface. It is a living, breathing organ system that stands at the threshold between self and world. It defends, it feels, it regulates, it communicates, and it heals. To study it is to study the boundary between the inner life of the body and the outer life of the environment. As we move further in this lecture, each part will be explored in greater depth. The layers of the skin, the pigments that give it color, the functions of hair and nails, and the role of glands in maintaining balance. For now, let us rest in the simple awareness that this system, so familiar and yet so intricate, is always working, always renewing, and always guarding us as we move through the gentle rhythm of life. 2. The skin is the body's largest organ. The skin is a marvel of design, both simple and complex, both delicate and resilient. To think of it merely as a surface covering would be to miss the depth of its importance. It is not a passive wrapping but an organ in its own right, the largest organ of the human body, accounting for around 16% of body weight and stretching across nearly 2 square meters in the average adult. With its remarkable reach, the skin is at once a boundary and a bridge. It separates us from the outside world, shielding the delicate machinery of our inner systems, while also linking us to the environment through sensation, regulation, and exchange. It is the part of us most visible to others, a canvas that reflects health, age, and ancestry. And it is also the part that works tirelessly in silence, demanding little attention yet offering constant service. To better appreciate the skin as an organ, one might think of it as a living tapestry, woven of countless threads, each thread a cell, each pattern and arrangement of tissues and functions that combine into the whole. The skin is not uniform but layered, and within each layer, processes unfold with a quiet rhythm that sustains life. The outermost layer, known as the epidermis, is a thin sheet when viewed in cross-section, yet it is a fortress at the microscopic level. Its cells are densely packed, filled with keratin, a protein that strengthens and waterproofs, forming a barrier against the intrusion of microbes and the loss of precious water. The cells of the epidermis are constantly renewed. Born in the deeper regions, they gradually migrate upward, flattening and hardening as they ascend, until finally they reach the surface, where they exist briefly as protective tiles before being shed. This cycle takes about 4 weeks, a month-long journey from birth to release, repeated over and over throughout a lifetime. Beneath the epidermis lies the dermis, the thicker, more robust, middle layer of skin. If the epidermis is a protective wall, the dermis is the support structure behind it, filled with connective tissue, blood vessels, and nerves. The dermis is what gives skin its resilience, its elasticity, its ability to stretch and move without tearing. Collagen fibers provide strength, while elastin fibers allow flexibility. Within this living fabric lie the roots of hair follicles, the coiled tubes of sweat glands, and the ducts of sebaceous glands that secrete oil. It is also the layer that houses an intricate network of blood vessels, bringing nutrients to nourish the skin and removing waste products, while also playing a vital role in temperature regulation. Nerve endings, finely tuned and abundant, are woven throughout, granting the skin its remarkable ability to sense. Even deeper still is the hypodermis, sometimes called the subcutaneous layer. This is not skin in the strictest sense, but rather the foundation upon which the skin rests. It is composed mainly of fat and connective tissue, serving as both cushion and insulation. Here, energy is stored in fat cells, available for future use, while the soft padding helps absorb shocks and protect underlying muscles and organs. The hypodermis also plays a role in regulating temperature, slowing the loss of heat in cold conditions and buffering the body against extremes. It anchors the skin to deeper structures, holding the outer organ system firmly yet flexibly to the body. What makes the skin so extraordinary as an organ is not only its layered structure but also its versatile functions. It is a guardian against physical injury, resisting abrasion and shielding against harmful radiation from the sun. It is a regulator of temperature, opening blood vessels to release heat and narrowing them to conserve it, producing sweat that cools as it evaporates. It is a communicator, flushing with color in moments of emotion, paling in fear, or glowing with exertion. It is a sensory organ, allowing us to feel the brush of air, the warmth of fire, the coolness of water, the firmness of stone. It is also a participant in immunity, containing specialized cells that patrol the surface and respond to the presence of pathogens, forming part of the body's first line of defense. The size and prominence of the skin make it uniquely vulnerable, yet also uniquely adaptive. It must withstand constant challenges, the pressure of touch, the stretch of movement, the scrape of contact, the drying of wind, the burning of sun, and the attack of microorganisms. To meet these challenges, the skin is not static but alive, constantly regenerating, constantly adjusting. When injured, it repairs itself with remarkable efficiency. When exposed to sunlight, it produces melanin, a pigment that darkens the skin and protects against ultraviolet damage. When moisture is scarce, it increases oil production to maintain suppleness. These are not conscious actions but instinctive responses embedded within the very design of the organ. The role of the skin as the body's largest organ extends beyond protection and regulation to include a quiet but essential function in metabolism. It is through the skin, in the presence of sunlight, that the body begins the synthesis of vitamin D, a nutrient crucial for bone health and for many other processes. Without the skin's capacity to convert sunlight into this vital compound, the body would struggle to maintain balance in calcium and phosphorus, minerals necessary for strength and stability. In this way, the skin is a mediator between the physical environment and the internal chemistry of life, turning light into nourishment. One of the most profound aspects of the skin's vast surface area is its role as a communicator between individuals. While speech conveys words, the skin conveys states of being. A blush signals embarrassment or warmth. A pallor may reveal shock or illness. The sweat upon a brow hints at exertion, stress, or heat. Even the texture and appearance of skin, whether smooth, weathered, youthful, or aged, become part of how humans perceive and relate to one another. In this sense, the skin is not only an organ of biology but also of social and emotional expression, linking the inner world of the self with the outer world of others. Though it stretches seamlessly across the body, the skin is not uniform everywhere. The thickness of the skin varies, thinner on the eyelids, where delicacy is required, and thicker on the soles of the feet, where endurance is essential. The distribution of hair differs across regions, as does the density of glands. These variations reflect the adaptability of the organ, its capacity to tailor itself to the needs of specific areas, while remaining part of the continuous whole. The skin, as the body's largest organ, is also deeply symbolic. It marks the boundary of identity, defining where one person ends and the world begins. It is the canvas upon which life paints its marks, through scars, freckles, tattoos, and wrinkles. It is the sense of presence when touched, the awareness of being alive when air passes across it. It is both barrier and bridge, both shield and communicator, both ancient in its design and immediate in its function. To call the skin the largest organ is to acknowledge its size, but to truly appreciate it is to see the fullness of its role. It is the body's protector, regulator, sensor, and communicator. It is the interface between biology and environment, between self and other, between inner life and outer world. As we continue in this calm exploration of the integumentary system, we will move next into the layers of the skin more closely, examining the epidermis, the dermis, and the hypodermis, each with its own quiet functions, each contributing to the whole. For now, it is enough to rest in the awareness that the skin, vast and ever-present, is a living organ that never leaves our side, a guardian and companion throughout the entire course of life. Part 3. Layers of the skin. An overview. The skin, though it appears to be a single smooth surface when we glance at it in the mirror or feel it with our hands, is in truth a layered structure, each level with its own purpose, each one contributing to the quiet and unbroken function of the whole. These layers work in harmony, like movements in a gentle symphony, each distinct and yet inseparable. To understand the skin as the largest organ of the human body, one must look beneath the surface and appreciate the intricate architecture that lies within. The three principal layers are the epidermis, the dermis, and the hypodermis. Together, they form not only a barrier against the external world, but also a living tissue that regulates, senses, repairs, and connects. Though they differ in thickness, structure, and composition, they form a continuum, each relying upon the other in a seamless partnership. The outermost layer, the epidermis, is the surface that greets the world, though it is far from a static shell. It is composed primarily of keratinocytes, cells filled with the protein keratin that gives strength and water resistance. These cells are not fixed in place, but are part of an endless cycle of renewal. Deep in the basal layer of the epidermis, new cells are born through the division of stem cells. Gradually, they move upward, changing as they rise, flattening, losing their nuclei, and becoming more filled with keratin. By the time they reach the surface, they have transformed into flattened, lifeless scales that form a protective shield. After a short time, these scales are shed, invisible in the day-to-day but immense in quantity, for millions of skin cells are released each day, replaced by those coming up behind them. The cycle takes roughly 4 weeks, a rhythm of birth, migration, and release that continues unbroken throughout life. Interwoven among the keratinocytes are other specialized cells. Melanocytes, for example, are responsible for producing melanin, the pigment that gives color to the skin and provides protection against ultraviolet radiation from the sun. The distribution and activity of these melanocytes contribute to the wide range of skin tones across humanity. There are also Langerhans cells, part of the immune system, which patrol the epidermis and act as sentinels, detecting potential threats. And in certain regions, Merkel cells, sensitive to touch, play a role in the perception of pressure and texture. Though the epidermis is thin, ranging from fractions of a millimeter on the eyelids to several millimeters on the palms and soles, it is far from simple. It is a living frontier, a dynamic shield, and a place where protection, sensation, and defense all converge. Beneath the epidermis lies the dermis, a thicker and more complex layer that provides the skin with its resilience and strength. If the epidermis is the protective wall, the dermis is the supportive framework behind it. It is composed primarily of connective tissue, dense with collagen fibers that lend strength and elastin fibers that grant flexibility. These fibers create a matrix that not only supports the epidermis above, but also houses many of the structures that allow the skin to function. Within the dermis lie blood vessels, carrying nutrients to the skin and removing waste products. These vessels also play a crucial role in regulating temperature, widening to release heat, and narrowing to conserve it. Intertwined with the vessels are lymphatic channels, part of the body's immune system, which help maintain fluid balance and defend against infection. The dermis is also rich in sensory nerves, tiny endings spread throughout, attuned to different kinds of stimuli. Some respond to light touch, allowing you to feel the gentlest brush against the surface. Others respond to pressure, to vibration, to warmth or cold, and to pain. These receptors make the skin one of the body's most sensitive and communicative organs, able to detect a wide spectrum of sensations. Embedded in the dermis are also the roots of hair follicles, each one a small invagination of the epidermis that dips deep into this supportive layer. Attached to these follicles are tiny muscles, the erector pili, which contract to lift the hair in the familiar pattern of goosebumps. Alongside the follicles are sebaceous glands, which secrete sebum, an oily substance that helps keep the skin supple and resistant to water loss. Sweat glands are also found here, coiled tubes that release perspiration to cool the body and aid in excretion. Together, these structures make the dermis a living environment, active and responsive, sustaining the life of the skin above and contributing to the balance of the body as a whole. Below the dermis lies the hypodermis, also known as the subcutaneous tissue. Though not always considered part of the skin in the strictest sense, it is intimately connected and essential to its function. This layer is composed primarily of adipose tissue, or fat, interspersed with connective tissue and larger blood vessels. The hypodermis acts as a cushion, protecting underlying muscles and organs from shocks and impacts. It also serves as insulation, slowing the loss of heat and helping to maintain a stable internal temperature. In addition, it functions as a storehouse of energy, with fat cells providing reserves that can be drawn upon when needed. The hypodermis anchors the skin to deeper structures, yet does so in a way that allows flexibility, so the skin can move with the body rather than being rigidly fixed. Together, these three layers form a unified organ system. The epidermis, though it has no blood vessels of its own, is sustained by the blood supply of the dermis below. The dermis, in turn, is protected by the epidermis above and cushioned by the hypodermis beneath. The hypodermis depends upon the integrity of the skin layers above to shield it from injury and infection. None can function in isolation. It is in their integration that the skin's true strength lies. This layered design allows the skin to serve multiple roles at once: barrier, regulator, sensor, and communicator without compromise. The layers of the skin also demonstrate the principle of constant change within stability. On the surface, the epidermis is renewed in a steady cycle, cells rising and falling away in a rhythm that has no beginning and no end. In the dermis, collagen and elastin are continually remodeled, adapting to the stresses placed upon the skin by movement, stretching, and the passage of time. In the hypodermis, fat stores are filled and drawn upon according to the body's needs, adjusting quietly to shifts in nourishment and demand. Each layer is alive, dynamic, and capable of repair. When the skin is cut, the epidermis and dermis both participate in the healing process, closing the wound with new tissue, while the hypodermis provides the reserves needed to sustain repair. To appreciate the layers of the skin is to appreciate the elegance of nature's design. At the surface, a shield that renews itself ceaselessly. Beneath it, a framework that sustains, senses, and supports. And deeper still, a foundation that cushions, stores, and insulates. Each layer has its own identity, yet together they are one. When we think of the skin as the body's largest organ, we are not thinking of a single sheet, but of this intricate layered structure, each part indispensable, each part quietly performing its role in the unending work of maintaining balance, protection, and connection. As we move forward, we will explore these layers more closely, beginning with the epidermis, the outermost surface, where renewal, pigmentation, and protection take place. For now, it is enough to rest in the knowledge that beneath what seems a simple surface lies a world of depth, order, and harmony, a layered organ system that stands at the frontier between body and world, silent and constant in its service. 4. The epidermis is the most visible part of the integumentary system, the layer of the skin that stands as the first line of defense between the body and the external world. Though it is thinner than a sheet of paper in many regions, it serves as a resilient, ever-renewing barrier that guards against harm, regulates exchanges with the environment, and communicates subtle signs of health and vitality. Its role is immense when one considers its delicate structure, for the epidermis is not vascular. It contains no blood vessels of its own. Instead, it is nourished indirectly by diffusion from the blood vessels of the dermis below. Yet despite its seeming fragility, the epidermis endures constant friction, radiation, exposure, and injury, regenerating itself with quiet persistence. It is both shield and interface, both barrier and living tissue. The epidermis is composed primarily of keratinocytes, cells that produce the protein keratin, which is responsible for much of the strength and waterproofing of the skin. These cells do not remain fixed but live in a cycle of birth, transformation, and eventual shedding. At the base of the epidermis lies a layer of stem cells that continuously divide, giving rise to new keratinocytes. As these cells are produced, they slowly migrate upward through the layers of the epidermis. During this upward journey, they undergo a process of differentiation, changing their form and function as they ascend. Eventually, at the surface, they flatten into dead, keratin-rich scales that form the outermost protective covering. These scales remain briefly before they are shed, falling away invisibly, replaced by others rising from below. The entire process, from birth to shedding, takes approximately 4 weeks, a constant cycle of renewal that continues throughout life. The epidermis is not uniform but structured in distinct layers, or strata. At the deepest point lies the stratum basale, also known as the basal layer. This is a single row of cells resting on the basement membrane, where active cell division occurs. The basal layer is also home to melanocytes, specialized cells that produce melanin, the pigment responsible for skin color and protection against ultraviolet radiation. The activity of melanocytes is not uniform among individuals, and differences in melanin production contribute to the diversity of skin tones across human populations. Here, too, are Merkel cells, associated with the sense of touch, providing fine sensory input in regions such as the fingertips and lips. Above the basal layer lies the stratum spinosum, or the spiny layer, so named because of the spiny appearance of its cells under a microscope. These cells are connected by numerous desmosomes, strong junctions that bind the keratinocytes together, lending mechanical strength to the skin. The spinosum is also populated by Langerhans cells, which serve as immune sentinels. They patrol the epidermis, detecting foreign substances or pathogens, and alerting the immune system to potential threats. Thus, even at this microscopic level, the skin is actively defending the body from invasion. The next layer is the stratum granulosum, where the keratinocytes begin to flatten further and accumulate granules of keratohyalin and lamellar bodies. These granules play a vital role in the formation of the waterproof barrier of the skin. The lamellar bodies release lipids into the extracellular space, creating a seal that prevents excessive water loss from the body and blocks the entry of harmful substances. At this stage, the cells are on the threshold of death, losing their nuclei and organelles as they prepare to transition into the protective scales of the uppermost layers. In certain areas of the body, particularly the thick skin of the palms and soles, an additional layer appears above the granulosum, the stratum lucidum. This translucent layer provides an extra degree of toughness, reinforcing the barrier in places subject to friction and pressure. It is absent in thinner skin, such as that found on the eyelids or inner arms, but its presence in thickened regions is a testament to the adaptability of the epidermis to local demands. At the very surface lies the stratum corneum, the horn-like layer that is the ultimate shield. Composed entirely of flattened, keratin-filled cells, it is tough, resilient, and expendable. These cells, often referred to as corneocytes, are essentially lifeless shells, but their arrangement in layers provides a durable defense against the environment. The stratum corneum varies in thickness depending on location, thin on delicate areas, and up to dozens of layers thick on the soles of the feet. It is this outermost layer that is constantly shed, a silent snowfall of cells that fall unnoticed, but remind us of the perpetual cycle of renewal at work. The epidermis performs more than a mechanical function. It is an active participant in immunity, housing Langerhans cells that recognize and process foreign invaders, serving as a first alarm to the deeper immune system. It is also involved in the production of vitamin D. When exposed to ultraviolet B radiation from sunlight, molecules in the epidermis are converted into a precursor of vitamin D, which is then modified in the liver and kidneys into its active form. This process is crucial for calcium balance and bone health, linking the skin directly to one of the most fundamental aspects of human physiology. The pigmentation of the epidermis, provided by melanocytes, plays a particularly important role in adaptation. Melanin protects against the damaging effects of ultraviolet radiation, reducing the risk of DNA damage that can lead to cancer. The variations in skin tone observed across the world are evolutionary responses to differing levels of sunlight. In regions with intense sun exposure, darker pigmentation provides stronger protection, while in regions with less sunlight, lighter pigmentation allows greater penetration of ultraviolet light for vitamin D production. This balance reflects the delicate interplay between protection and necessity, between shielding and synthesis. The epidermis also demonstrates remarkable healing capacity. When a superficial wound occurs, cells at the edges of the wound flatten and migrate inward, closing the gap. Division increases in the basal layer, producing new cells to replace those lost. Within days, a small cut may be sealed, and within weeks, the barrier is restored. In deeper injuries that extend into the dermis, the process becomes more complex, involving clotting, inflammation, and the formation of scar tissue. But the epidermis always participates, renewing the surface covering and restoring the protective barrier. One of the subtle beauties of the epidermis lies in its quiet communication. Though we rarely think of it consciously, it reflects health in countless ways. Dryness, pallor, changes in pigmentation, rashes, or lesions all carry information about the body's internal state. A physician examining the skin may glean clues about nutrition, circulation, immunity, or systemic disease, all from the surface of the epidermis. It is at once a shield and a messenger, a barrier and a window. When considered in its entirety, the epidermis is an extraordinary organ within an organ. It is thin, delicate, and constantly renewed, yet its functions are profound. It defends against pathogens, prevents dehydration, produces vitamin D, adapts to sunlight, communicates sensory input, and even provides clues to overall health. It is a living system in perpetual motion, cells rising from the depths, changing as they ascend, and finally giving themselves to the task of protection before being shed. This cycle, invisible in daily life, is as steady as the turning of the earth, a rhythm of renewal that accompanies us from birth to death. As we drift gently deeper into the integumentary system, the focus will soon shift to the dermis, the supportive layer beneath the epidermis, where strength, sensation, and resilience reside. For now, the epidermis stands as a reminder that even the thinnest, most delicate structures of the body can hold immense power and significance, guarding life quietly, faithfully, and without rest. 5. The dermis. Beneath the delicate yet resilient sheet of the epidermis lies the dermis, a thicker, deeper, and far more intricate layer of the skin that provides structure, strength, and vitality to the entire integumentary system. If the epidermis is the visible shield, the dermis is the supportive foundation that ensures that shield remains functional, nourished, and sensitive to the world. It is here that we find the roots of hair, the sweat glands that cool us, the sebaceous glands that protect with oil, the blood vessels that nourish, and the nerves that bring sensation to life. The dermis is not simply a passive layer, but a bustling landscape of connective tissue, fibers, vessels, and sensory structures, each one contributing to the remarkable versatility of the skin as an organ. The dermis is significantly thicker than the epidermis, ranging from about 0.5 millimeter on the eyelids to several millimeters on the palms, soles, and back. This thickness reflects its role as a structural layer, designed to withstand stresses and strains while also remaining flexible enough to accommodate movement. The dermis itself is composed primarily of connective tissue, with collagen and elastin fibers arranged in a supportive matrix. Collagen, a protein that provides tensile strength, ensures that the skin does not tear under pressure. Elastin, as its name suggests, imparts elasticity, allowing the skin to stretch and return to its original shape. Together, these fibers create a living fabric that is both strong and supple, capable of enduring constant mechanical forces without losing integrity. Within this connective tissue, countless blood vessels branch and weave, carrying life to the otherwise avascular epidermis above. The capillaries that extend into the upper regions of the dermis supply oxygen and nutrients that diffuse upward, sustaining the keratinocytes of the epidermis. These vessels also play a crucial role in thermoregulation. When the body overheats, the vessels dilate, allowing greater blood flow near the surface, where heat can dissipate into the air. When the body grows cold, the vessels constrict, conserving warmth by keeping blood closer to the core. In this way, the dermis serves as a dynamic radiator, adjusting continuously to maintain the narrow range of internal temperature upon which life depends. Threaded throughout the dermis are countless sensory receptors, making the skin one of the most sensitive organs of the body. These receptors take many forms, each tuned to a particular type of stimulus. Some detect the lightest brush against the surface, while others respond to deeper pressure. There are receptors for vibration, for warmth and cold, and for pain, each one sending signals along nerve fibers to the brain. The ability to feel a soft caress, the sharpness of a pin, or the warmth of sunlight is due to the dermis and its rich network of nerves. Without it, the skin would be a silent shield, protective but unfeeling. With it, the skin becomes a sensory organ of extraordinary refinement, a constant communicator with the nervous system, alerting us to danger, guiding our interactions, and enriching our experience of the world. The dermis is also the home of hair follicles, small invaginations of the epidermis that extend deep into this supportive layer. At the base of each follicle lies the hair bulb, where living cells divide and push upward, gradually forming the hair shaft that emerges at the surface. The follicle is accompanied by sebaceous glands, which secrete an oily substance called sebum. This oil coats the hair and skin, preventing excessive dryness and providing a barrier against water loss and microbial invasion. Attached to each follicle is a tiny muscle called the erector pili. When this muscle contracts, usually in response to cold or emotional states, it causes the hair to stand upright, producing the familiar pattern of goosebumps. Though in humans this response is more symbolic than functional. In animals with thicker coats, it serves to trap air and provide insulation. Sweat glands, too, are embedded in the dermis, coiled tubular structures that open to the surface through ducts. These glands come in two types. Eccrine glands are widespread across the body and produce a watery sweat that evaporates to cool the body. Apocrine glands, found in regions such as the armpits and groin, produce a thicker secretion that becomes odorous when metabolized by skin bacteria. Both types of glands are essential, not only for temperature regulation, but also for excretion and, in the case of apocrine glands, for subtle roles in social communication. The steady production and release of sweat is a reminder that the dermis is not static but constantly active, adjusting fluid balance, cooling the body, and contributing to the chemistry of the skin. The dermis also plays a vital role in wound healing. When the skin is injured, blood vessels in the dermis constrict briefly to minimize blood loss before widening to allow immune cells and clotting factors to flood the area. Fibroblasts, specialized cells within the dermis, migrate into the wound and begin producing collagen, laying down a scaffold upon which new tissue can form. Over time, this process restores the structure of the dermis, though scars may remain as a testament to the repair. The ability of the dermis to regenerate connective tissue and to support the renewal of the epidermis above it ensures that the skin, though vulnerable to injury, can recover and continue its protective role. The dermis is not uniform but organized into two regions: the papillary dermis and the reticular dermis. The papillary dermis, the uppermost portion, is composed of loose connective tissue with thin collagen fibers. It interdigitates with the epidermis, forming ridges and valleys that increase the surface area for exchange. These ridges are visible on the fingertips as fingerprints, unique to each individual. The reticular dermis, by contrast, is thicker and denser, with bundles of collagen that provide the majority of the skin's strength. Within this deeper layer lie the roots of hair follicles, sweat glands, sebaceous glands, and larger blood vessels. Together, these regions ensure that the dermis is both supportive and adaptable, able to sustain the needs of the epidermis and respond to the demands of the environment. Another important aspect of the dermis is its contribution to appearance and aging. With youth, collagen and elastin are abundant, keeping the skin firm and resilient. Over time, however, the production of these fibers slows, and the existing fibers begin to fragment. The result is a gradual loss of elasticity, leading to wrinkles and sagging. Sun exposure accelerates this process by damaging collagen and promoting the breakdown of elastin. Thus, the condition of the dermis is a reflection of both time and experience, a record of age and environment written into the fabric of the skin. Though often hidden beneath the epidermis, the dermis is in many ways the heart of the skin. It provides the structural framework, the nourishment, the sensation, and the regenerative capacity that allow the skin to function as an organ. Without it, the epidermis would wither, insensate, and unsupported. With it, the skin becomes a living, feeling, adaptable system, able to withstand the demands of life and to respond with quiet resilience. The dermis is a reminder that strength need not be rigid, that resilience can be supple, and that the foundations of life are often hidden from view, working tirelessly without drawing attention to themselves. As the journey through the integumentary system continues, the focus will turn next to the hypodermis, the deepest layer of this protective covering, where cushioning, insulation, and energy storage take place. For now, the dermis stands revealed as the strong yet sensitive core of the skin, a living layer that sustains and protects, quietly serving in ways both obvious and unseen, a reminder of the profound complexity that lies beneath the surface of what seems so simple. 6. The hypodermis. Beneath the epidermis and dermis lies the deepest layer of the skin, known as the hypodermis, or subcutaneous tissue. Though it is often overlooked when compared to the more visible and active layers above, the hypodermis is no less important. It is the foundation upon which the skin rests, a layer of cushioning and insulation that not only protects the body from external forces, but also provides energy reserves and helps regulate temperature. While the epidermis guards and the dermis supports, the hypodermis steadies, anchoring the skin to deeper structures like muscles and bones, while still allowing the flexibility needed for smooth, fluid movement. Without this base, the outer layers would be fragile, prone to injury, and unable to withstand the demands of daily life. The hypodermis is composed primarily of adipose tissue, or fat, interspersed with connective tissue and larger blood vessels. The fat cells, known as adipocytes, cluster in lobules separated by thin partitions of connective fibers. These adipocytes serve as storage units, holding reserves of energy in the form of triglycerides. When the body requires extra fuel, whether during fasting, physical exertion, or times of need, the triglycerides are broken down into fatty acids and glycerol, which enter the bloodstream and supply energy to cells throughout the body. In this way, the hypodermis functions as both pantry and bank, storing energy when it is plentiful and releasing it when it is scarce. The balance between storage and release is delicate, influenced by hormones, nutrition, and overall metabolic state, yet always guided by the quiet steadiness of this deep layer. Beyond energy storage, the hypodermis also provides essential insulation. Fat, by its very nature, conducts heat poorly, and so the presence of adipose tissue beneath the skin creates a thermal barrier. This barrier slows the loss of body heat in cold conditions and helps maintain a stable internal environment regardless of fluctuations in the external world. In warm climates or during exertion, the hypodermis works in concert with the dermis above, which dilates its vessels and produces sweat, ensuring that the body does not overheat. The hypodermis, then, is not passive in temperature regulation but an active partner, retaining warmth when needed and forming part of the complex system that maintains homeostasis. Another critical role of the hypodermis is cushioning. Daily life exposes the body to countless small impacts, pressures, and stresses. When you sit, the weight of your body presses against the bones of your hips. When you walk or run, the force of impact travels upward from the ground, through your feet and legs. The hypodermis absorbs and disperses these forces, preventing damage to deeper tissues. It acts as a shock absorber, softening blows and reducing wear on muscles, tendons, and bones. Without this protective padding, even ordinary movements would place excessive strain on the body, and injury would be far more common. The connective tissue of the hypodermis also plays a structural role, attaching the skin to the underlying fascia and muscles. These connections are not rigid but flexible, allowing the skin to move with the body rather than tear or separate under stress. When you pinch the skin on your arm and it lifts slightly, it is the looseness of the hypodermis that allows this movement. Yet that looseness does not imply weakness. It is carefully balanced to provide both security and mobility, anchoring the skin firmly enough to prevent detachment while permitting the range of motion necessary for daily life. Blood vessels in the hypodermis are larger than those found in the dermis, forming a vascular network that supplies the skin and contributes to overall circulation. These vessels serve as reservoirs, adjusting blood flow according to the body's needs. In times of warmth, blood flow to the skin increases, enhancing heat loss. In times of cold, blood flow is reduced, conserving warmth. Because of its rich blood supply, the hypodermis is also important in the delivery of medications. Many drugs, such as insulin, are administered by subcutaneous injection, where they are absorbed slowly and steadily into the bloodstream through this vascular layer. This method takes advantage of the hypodermis's unique properties, its blend of fat for cushioning and vessels for absorption, to provide controlled and reliable delivery of medicine. The thickness of the hypodermis varies widely, depending on location, age, sex, and nutrition. In some regions, such as the eyelids, it is very thin, while in others, such as the abdomen, buttocks, and thighs, it may be thick and prominent. Women, on average, tend to have a thicker hypodermis than men, reflecting differences in fat distribution and storage, influenced by hormones such as estrogen. As age advances, the hypodermis tends to thin, particularly in the face and hands, contributing to the visible signs of aging, such as sagging and wrinkling. Loss of fat in these regions diminishes the cushioning effect, making the skin appear more fragile and less resilient. Thus, the hypodermis not only supports physical function, but also influences outward appearance across the lifespan. The hypodermis is also involved in communication at the molecular level. Adipose tissue is no longer seen as merely inert storage, but as an active endocrine organ. Fat cells release signaling molecules, known as adipokines, that influence metabolism, appetite, and inflammation. These signals reach distant organs, affecting the liver, muscles, and even the brain. In this way, the hypodermis participates in regulating energy balance across the entire body. Too little adipose tissue can lead to problems with insulation and energy reserves, while too much can contribute to metabolic disturbances, highlighting the delicate balance required for health. In addition to its structural and metabolic roles, the hypodermis also contributes to wound healing. When injury extends deep enough to reach this layer, fibroblasts and other cells in the connective tissue become activated, producing collagen and other extracellular components needed to repair the damage. Blood vessels in the hypodermis support the inflammatory response, bringing immune cells to the site of injury to fight infection and begin the process of repair. Though deeper wounds take longer to heal, the participation of the hypodermis ensures that the process is sustained, providing both cells and resources for regeneration. Despite being the deepest layer of the skin, the hypodermis should not be thought of as hidden or inactive. Its presence is felt every time we are shielded from the cold, every time a blow is softened, every time energy is drawn upon in times of need. It is a foundation that supports without drawing attention, a silent partner to the epidermis and dermis above. Without it, the skin would lack both stability and resilience, unable to fulfill its role as the body's protector. With it, the integumentary system becomes complete, a layered organ that guards, supports, cushions, and connects. To reflect upon the hypodermis is to reflect upon the quiet foundations of life itself, like the roots of a tree that anchor it firmly into the ground, unseen yet indispensable. The hypodermis lies beneath, supporting all that rests above. It is steady, dependable, and enduring, a reminder that strength often lies not in what is seen but in what is hidden, providing security in silence, holding us together in ways we rarely pause to notice. As the exploration of the integumentary system continues, attention will soon turn to the functions of the skin as a whole, beginning with its role as a protector. For now, the hypodermis stands as the base, a living cushion that steadies and sustains, working quietly and without rest beneath the visible layers, a foundation of softness and strength upon which the human form depends. 7. Skin functions. Protection. The skin's most fundamental role, the one that makes it indispensable to life, is protection. Day and night, in silence and without pause. It shields the body from countless threats, both seen and unseen. This protective function is not limited to a single defense, but is instead a vast network of barriers, responses, and adaptations that together form a guardian of remarkable efficiency. When we think of protection, we might imagine armor or clothing, but the skin is a living barrier, one that renews itself, repairs itself, and adjusts continually to the environment. It is a shield that grows with us, that bends but does not easily break, that guards us from the world, while still allowing the gentle exchanges necessary for life. One of the primary dangers the skin protects against is mechanical injury. Every moment of life brings contact, brushing against a wall, pressing against the ground, holding tools, or simply moving through the air. The skin absorbs these minor abrasions and pressures, its layered structure distributing forces so that deeper tissues remain safe. The epidermis, with its keratinized cells, forms a tough outer covering that resists tearing and scraping, while the dermis below provides elasticity and strength, allowing the skin to flex and stretch without splitting. In areas of frequent contact, such as the palms of the hands or the soles of the feet, The skin thickens into calluses, a quiet adaptation that reinforces protection where it is most needed. This ability to adapt to pressure and friction shows how the skin's defenses are not rigid but alive, capable of strengthening in response to demand. Beyond physical abrasion, the skin protects against chemical harm. The outer barrier of keratin and lipids prevents many substances from penetrating into the body, shielding us from toxins, irritants, and pollutants in the environment. Sweat and sebum, the oily secretions of sebaceous glands, also contribute to this defense, forming a thin acidic film across the surface, known as the acid mantle. This layer, with a pH slightly below neutral, discourages the growth of harmful bacteria and fungi, while supporting the balance of beneficial microbes that dwell naturally on the skin. These microscopic inhabitants, collectively known as the skin microbiome, form part of our protective shield. They compete with pathogens for space and resources, producing substances that inhibit invaders and reinforcing the skin's barrier. In this way, the skin is not a solitary guardian but part of a living partnership with trillions of microbes, all working quietly together to defend the body. The skin also protects against the invisible yet powerful rays of the sun. Ultraviolet radiation, though essential for the production of vitamin D, can also damage DNA and accelerate the breakdown of tissues. To guard against this, melanocytes in the epidermis produce melanin, the pigment that absorbs and disperses ultraviolet light. This pigment is distributed to surrounding keratinocytes, forming a shield over their nuclei, protecting the delicate genetic material within from mutation. The amount and type of melanin produced vary among individuals, reflecting both genetic inheritance and environmental adaptation. In regions with intense sunlight, darker pigmentation provides greater protection, while in areas with less sun, lighter skin allows for more effective vitamin D synthesis. This balance between defense and necessity illustrates the skin's role as a mediator between the inner body and the outer world, adapting to protect without cutting off the vital benefits of sunlight. Another aspect of protection lies in the skin's role as part of the immune system. Langerhans cells in the epidermis patrol constantly, sampling the environment for signs of danger. When they detect a foreign substance or invading microbe, they alert the immune system, triggering a cascade of responses that mobilize defenses throughout the body. Deeper in the dermis, immune cells stand ready to respond to breaches, coordinating inflammation, repair, and defense. This surveillance is constant, a silent watch that ensures threats are identified and addressed before they can spread. Without the immune functions of the skin, the body would be far more vulnerable to infection, open to the countless microbes that live on its surface or surround us in the air. The skin also plays a role in protecting against dehydration, a danger more subtle than injury or infection, but no less serious. The body's tissues require a delicate balance of water to function properly, and without a barrier, evaporation would quickly drain the body of its vital fluid. The stratum corneum, the outermost layer of the epidermis, prevents this loss. Its keratinized cells are arranged like bricks, while lipids secreted from lamellar bodies act as mortar, sealing the spaces between them. Together, they form a waterproof barrier that minimizes water loss, ensuring that the body retains the moisture it needs to survive. Even in dry environments, this barrier slows evaporation, maintaining internal stability despite external conditions. Protection is also extended to sensitive organs and tissues through specialized structures of the integumentary system. Eyelashes shield the eyes from dust and debris, while eyebrows help divert sweat away. Hair across the body provides a light sensory shield, alerting us to the presence of insects or particles before they reach the skin. Nails protect the delicate tips of fingers and toes, allowing them to grasp, touch, and manipulate the environment without injury. These extensions of the skin, though often taken for granted, are part of the same protective system, each one adapted for its own role in defense. The protective capacity of the skin extends even to the process of healing. When the barrier is breached by a cut or scrape, the skin responds instantly. Blood clotting begins within moments, sealing the wound and preventing further loss of fluid or entry of pathogens. Inflammation follows, bringing immune cells to fight infection and clear debris. Fibroblasts in the dermis begin to lay down new collagen, forming the framework for repair. Within days, new cells rise from the basal layer of the epidermis to cover the wound, and within weeks, the barrier is restored. Though scars may remain, the function of protection is swiftly renewed, a reminder of the skin's resilience and dedication to its role as guardian. It is worth noting that the skin's protective role extends beyond the purely physical. It also serves as a shield in social and emotional ways. Blushing, sweating, all of these responses communicate states of being without words, protecting social bonds, and signaling feelings before they are spoken. The condition of the skin, its color, its clarity, and its texture often conveys health or distress, warning others of illness or signaling vitality. In this sense, the skin protects not only the body but also the person within, acting as an interface between self and society. When viewed in its entirety, the protective function of the skin is astonishing in its breadth and depth. It shields against injury, chemicals, microbes, radiation, and dehydration. It collaborates with microbes to maintain balance, works with the immune system to repel invaders, and repairs itself when damaged. It adapts to the environment, thickening with friction, tanning with sun, and shedding with renewal. It cushions the vulnerable, guards the delicate, and signals the unseen. The skin is a living fortress, not static but responsive, not rigid but flexible, a shield that bends with the body and serves in silence. To appreciate the skin's role in protection is to appreciate the very possibility of life as we know it. Without this barrier, the inner systems of the body would be exposed and defenseless. With it, we are safeguarded, surrounded by a living shield that requires no conscious thought, no effort, and no command. It is always working, always present, always faithful. As the exploration continues, attention will soon shift to another of the skin's great functions: regulation, the delicate balancing of heat, moisture, and internal stability that ensures life proceeds smoothly despite the changing environment. But for now, the skin stands most clearly as protector, a quiet sentinel guarding us every moment of every day. 8. Skin functions. Regulation. The skin is not only a shield but also a regulator, quietly adjusting the internal conditions of the body so that life can proceed within its narrow range of balance. This regulatory role is one of its most remarkable functions, for the skin is constantly aware of the environment, constantly responding in ways that protect inner stability without our conscious effort. The world outside is filled with fluctuations, heat and cold, dryness and humidity, light and darkness, and yet within the body, conditions remain steady. This stability, known as homeostasis, is essential for survival, and the skin is one of the central guardians of its maintenance. One of the most important aspects of regulation carried out by the skin is the control of body temperature. The human body functions best within a very small range of temperatures, and even slight deviations can disrupt the chemistry of life. Too much heat, and proteins begin to lose their structure. Too much cold, and metabolic processes slow to dangerous levels. The skin, with its wide surface area and extensive blood supply, plays a key role in keeping temperature stable. When the body becomes warm, Whether from external heat or internal activity, the blood vessels in the dermis dilate. This widening allows more blood to flow near the surface, where heat can radiate outward into the surrounding air. At the same time, sweat glands begin to produce their clear, watery fluid. As sweat spreads across the skin and evaporates, it carries heat with it, cooling the body in a process both efficient and elegant. In contrast, when the environment is cold, the skin takes the opposite approach. Blood vessels constrict, reducing the flow of warm blood near the surface and conserving heat deep within the body's core. Tiny muscles at the base of each hair contract, lifting the hairs into the familiar pattern of goosebumps. In animals with thick fur, this traps a layer of insulating air. In humans, the effect is smaller, yet it remains as a vestige of our evolutionary past. Shivering may follow, generating heat through rapid muscular activity, but it is the skin that first acts to conserve warmth, narrowing the gateways through which heat might escape. These adjustments, dilation and constriction, sweating and goosebumps, take place without conscious thought, occurring in response to signals from the nervous system that monitors temperature continuously. Regulation by the skin extends beyond heat to include water balance. The body is composed largely of water, and its functions depend upon maintaining that water within precise limits. The outermost layer of the epidermis, the stratum corneum, serves as a barrier that prevents excessive evaporation. Its keratin-filled cells are arranged like tiles, while lipids secreted from deeper cells fill the spaces between, forming a seal that locks moisture in place. Even in dry environments, this barrier slows the escape of water, keeping the tissues beneath hydrated. At the same time, sweat glands can increase the release of fluid when needed, both to cool the body and to excrete waste products such as salts and urea. This dual-function conservation and controlled release allows the skin to manage water balance with subtle precision. The regulation of electrolytes is closely tied to this process. Sweat contains not only water but also sodium, potassium, and other ions essential to cellular function. By controlling the amount of sweat released, the skin contributes to maintaining the balance of these electrolytes. Though the kidneys play the primary role in regulation, the skin offers fine-tuned adjustments during periods of heat, exertion, or stress. The loss of salts through sweat can be significant, reminding us that the skin's regulatory role extends into the chemistry of life, as well as the mechanics of temperature and hydration. The skin also regulates exposure to sunlight. While ultraviolet radiation is potentially damaging, it is also necessary for the production of vitamin D, a compound vital for bone health and many metabolic processes. The skin manages this balance through the activity of melanocytes, which produce melanin to absorb and scatter ultraviolet light. Increased exposure leads to increased production, darkening the skin in a process we know as tanning. This response protects against overexposure, while still allowing some penetration of light to trigger vitamin D synthesis. It is an elegant adjustment, a natural calibration between risk and necessity, allowing the skin to regulate its relationship with sunlight in a way that serves the body as a whole. Another aspect of regulation lies in the interaction between the skin and the nervous system. Sensory receptors embedded in the dermis and epidermis constantly monitor pressure, temperature, and touch, feeding information to the brain. These receptors do more than convey sensations. They help regulate responses. A sudden drop in skin temperature, detected by thermoreceptors, may trigger shivering or vasoconstriction. An increase in warmth may lead to sweating and vasodilation. Even pain serves a regulatory purpose, signaling danger and prompting protective behaviors. The skin is thus not only a passive barrier but also an active participant in a network of regulation that extends throughout the body. In its regulatory role, The skin also interacts with the immune system. When microbes attempt to penetrate, the skin responds not only by blocking entry but by signaling deeper defenses. The acid mantle, created by sweat and sebum, discourages pathogens, while immune cells in the epidermis and dermis recognize invaders and trigger protective responses. This regulation of microbial balance ensures that beneficial organisms flourish while harmful ones are suppressed. It is a delicate equilibrium, one that illustrates the skin's capacity to manage not only physical variables like heat and water, but also biological variables like microbial populations. Regulation even extends to social and emotional expression. The flush of blood that warms the cheeks in embarrassment or exertion, the pallor that comes with fear, the sheen of sweat during stress. All of these are regulated responses that communicate inner states outwardly. They are part of the skin's role as a mediator between body and environment, allowing others to perceive emotions and conditions that lie within. While these responses may not regulate internal chemistry directly, they regulate interaction, shaping how humans connect and respond to one another. The skin's regulatory capacity is not uniform across its surface but varies according to need. The skin of the palms and soles, for example, is thick and specialized for protection, with abundant sweat glands, but no sebaceous glands. The scalp, by contrast, has dense hair follicles and sebaceous activity, reflecting its role in warmth and protection. The distribution of sweat glands, hair, and pigmentation reflects local demands, each region of the skin regulating in its own way, while contributing to the overall balance of the body. To reflect upon the skin's regulatory role is to marvel at its constant vigilance. Every second, it adjusts blood flow, monitors temperature, balances water, manages salts, and oversees the relationship with sunlight and microbes. It performs these tasks in silence, without conscious thought, so seamlessly that we rarely pause to notice. And yet, without these adjustments, life would quickly falter. Too much heat, too little water, too many microbes. Any of these would overwhelm the body, were it not for the skin's steady regulation. In essence, the skin is both guardian and governor, protector and regulator, a living surface that ensures the internal harmony of the body, despite the fluctuations of the external world. It is both barrier and bridge, keeping danger out while letting balance in. As the exploration of the integumentary system continues, attention will turn to the sensory role of the skin, the way it translates the world into sensation and connects the outer environment with the inner mind. For now, the skin's role in regulation reminds us that balance is not static but dynamic, a dance of adjustments carried out in silence, moment by moment, by the living fabric that surrounds us. 9. The sensory role of the skin. The skin is not only a shield and a regulator, but also one of the body's most remarkable sensory organs. It is through the skin that we encounter the world, feeling textures, temperatures, pressures, and movements that would otherwise remain hidden. Every brush of fabric, every warmth of sunlight, every drop of water on the surface of the body is translated into signals by the skin and sent inward to the brain, where they become sensation. This role is so constant and so natural that we rarely pause to notice it. Yet without the skin's sensory function, life would be profoundly diminished. The skin is our interface with the world, a living surface covered in receptors that transform the external environment into experience. The richness of skin sensation begins with the variety of sensory receptors embedded in its layers. These receptors are specialized nerve endings, each one tuned to a particular kind of stimulus. Some respond to the lightest touch, while others respond to deep pressure. Some detect warmth, while others respond to cold. Some are sensitive to vibration, while others alert us to pain. Together, they create a vast network of perception, allowing the skin to convey a spectrum of information to the nervous system. These signals travel along nerve fibers to the spinal cord and brain, where they are interpreted and integrated into our awareness. In this way, the skin is not only a protective covering but a constant communicator, linking the outer world to the inner mind. One of the most refined forms of sensation is the ability to detect light touch. Mechanoreceptors, such as Merkel cells and Meissner's corpuscles, are responsible for this function. Merkel cells, found in the basal layer of the epidermis, provide fine tactile discrimination, allowing us to perceive details such as the texture of fabric or the edges of an object. Meissner's corpuscles, located in the dermal papillae, are sensitive to light, touch, and low-frequency vibrations, responding to movements across the skin. These receptors are particularly abundant in areas such as the fingertips, lips, and tongue, regions of the body. Thanks to them, we can read the small ridges of a fingerprint, feel the softness of a petal, or sense the slightest movement of air. Other receptors respond to deeper pressure and sustained force. Pacinian corpuscles, large onion-shaped structures found deeper in the dermis and hypodermis, are exquisitely sensitive to vibration and pressure. They allow us to perceive when an object presses firmly against the skin or when vibrations travel through a surface. Ruffini endings, by contrast, respond to stretch, helping us perceive the movement and position of our skin and joints. Together, these receptors provide feedback not only about the external world, but also about the body itself, contributing to proprioception, the sense of body position that allows us to move smoothly and with coordination. Temperature is another dimension of sensation governed by the skin. Thermoreceptors respond to changes in heat and cold, signaling differences in the temperature of the environment. These receptors are free nerve endings scattered throughout the skin, each tuned to a different range. Some detect warmth, firing more rapidly as the skin heats, while others detect cold, firing when the temperature drops. The brain integrates these signals to form a perception of temperature, allowing us to distinguish between the comforting warmth of a blanket and the sharp chill of ice. These sensations guide behavior, prompting us to seek warmth when it is cold or shade when it is hot, ensuring survival through simple yet profound awareness. Perhaps the most vital sensory function of the skin is the perception of pain. Though unpleasant, pain is essential for protection, warning of damage, and prompting immediate response. Nociceptors, free nerve endings sensitive to harmful stimuli, detect extremes of temperature, mechanical injury, or chemical irritation. They send urgent signals to the brain, which interprets them as pain, compelling withdrawal, or avoidance. Without nociception, the body would be vulnerable to unnoticed harm, as in conditions where pain sensation is absent and injuries accumulate silently. Pain, though unwelcome, is a guardian, a sensory alarm that protects the body from further injury and promotes healing by discouraging use of damaged areas. Beyond these individual modalities, the sensory role of the skin is remarkable for its integration. The receptors do not act in isolation but in concert, painting a complete picture of the environment. When you pick up a cup of tea, the skin informs you of its smooth surface through mechanoreceptors, its warmth through thermoreceptors, its weight through pressure receptors, and, if too hot, its danger through nociceptors. The brain receives all of these signals almost simultaneously, weaving them into a unified perception that guides action. In this way, the skin becomes a canvas upon which the world is drawn, moment by moment, in sensations both subtle and vivid. The distribution of sensory receptors is not uniform but reflects the needs of the body. The fingertips, lips, and face are densely packed with receptors, providing acute sensitivity for exploration, communication, and interaction. The back, by contrast, has far fewer receptors, resulting in less precise sensation. This distribution illustrates the economy of the body, concentrating resources where they are most useful, while still maintaining general awareness across the entire surface. The fingertips can distinguish textures separated by less than a millimeter, while the back may perceive touches several centimeters apart as a single point. This variability ensures that the skin is both finely discriminating and broadly protective, sensitive where needed, and sufficient where less is required. The sensory role of the skin also extends into emotional and social life. A gentle touch can comfort, a caress can convey affection, and a handshake can signal trust. These experiences are mediated through the same receptors that detect texture and pressure, yet their meaning goes far beyond simple physical sensation. They shape relationships, communicate emotions, and foster bonds. The warmth of skin-to-skin contact in infancy is essential for development, while throughout life, touch remains a language of connection, one that speaks without words but is deeply understood. In this way, the sensory role of the skin transcends biology, becoming part of human culture and identity. It is also important to note how adaptable the sensory system of the skin is. Receptors can become more sensitive or less sensitive depending on circumstances. Prolonged exposure to cold, for example, may dull the response of thermoreceptors, while heightened attention can make the skin acutely aware of the faintest touch. The brain, too, plays a role, filtering sensory information so that only what is necessary reaches conscious awareness. This prevents us from being overwhelmed by constant input while still allowing immediate response to significant changes. Thus, the sensory system is both rich and efficient, alive with detail, yet selective in its focus. To reflect upon the sensory role of the skin is to recognize it as more than a covering. It is a field of awareness, a living surface that translates the world into sensation. It allows us to feel comfort and danger, warmth and cold, gentleness and pain. It guides our actions, protects our body, and connects us to others. Without it, life would be muted and vulnerable. With it, life is vivid, rich with touch, temperature, and awareness. The skin is at once guardian and interpreter, a boundary that feels and communicates, turning the silent forces of the world into the intimate language of sensation. As the journey into the integumentary system continues, attention will turn to pigmentation and melanin, the elements that give skin its diversity of color and its vital protection against the sun. For now, the sensory role of the skin reminds us that to live is not only to be shielded and regulated, but also to be aware, to feel the world through the delicate and constant language of touch. 10. Pigmentation and melanin. The colors of human skin, ranging from the palest ivory to the deepest ebony, represent one of the most visible forms of diversity among people. This variation is not only a feature of beauty and identity, but also a vital adaptation, grounded in biology and guided by evolution. The source of this remarkable diversity lies in melanin, a pigment produced within the skin, whose presence influences not only outward appearance, but also protection and health. To understand pigmentation is to explore a story that connects sunlight and biology, ancestry and adaptation, individual variation and shared humanity. Melanin is produced by specialized cells in the epidermis known as melanocytes. These cells are relatively few in number compared to the vast population of keratinocytes, yet their role is profound. A single melanocyte can extend branching processes like the delicate arms of a tree, transferring melanin to dozens of surrounding keratinocytes. Once inside these cells, the melanin gathers above the nucleus, forming a protective cap that shields the DNA from ultraviolet radiation. This protective function is essential, for ultraviolet light can damage genetic material, causing mutations that may lead to cancer. Thus, melanin acts as a natural sunscreen, reducing harm while allowing the body to benefit from the necessary effects of sunlight, such as the production of vitamin D. The differences in skin color across individuals and populations arise not from the number of melanocytes, but from their activity and the type of melanin produced. There are two primary forms: eumelanin, which appears brown to black, and pheomelanin, which appears yellow to reddish. The relative amounts of these two types, as well as the size and distribution of melanin granules, determine the color of skin, hair, and eyes. In darker skin, melanocytes produce more eumelanin, and the granules are larger, more dispersed, and more resistant to degradation. In lighter skin, fewer melanin granules are produced. They are smaller, and they are broken down more quickly. These subtle differences create the broad spectrum of human pigmentation, a gradient shaped by genetic inheritance and environmental influence. The distribution of pigmentation across the globe reflects the powerful influence of sunlight. In regions near the equator, where ultraviolet radiation is intense year-round, darker pigmentation provides a protective advantage, reducing the risk of DNA damage and sunburn. In contrast, in regions closer to the poles, where sunlight is weaker and seasonal, lighter pigmentation allows more ultraviolet light to penetrate, ensuring sufficient production of vitamin D. This balance between protection from damage and the need for vitamin D synthesis illustrates the adaptive nature of pigmentation. Over thousands of generations, populations living in different environments have developed pigmentation patterns suited to their conditions. A living record of humanity's journey across the earth, pigmentation also changes over time within individuals. Many infants are born with lighter skin that darkens in the months after birth as melanocyte activity increases. Exposure to sunlight stimulates melanocytes, increasing melanin production and leading to tanning, a temporary adjustment that enhances protection after exposure. This process is a clear example of the skin's adaptability, increasing its defense in response to environmental conditions. Conversely, in the absence of sunlight, pigmentation may fade, revealing the dynamic balance between environment and biology. Age also influences pigmentation, with freckles, age spots, and uneven coloration often appearing later in life due to cumulative sun exposure and changes in melanocyte function. Melanin's role is not limited to the skin. In the hair, its presence determines color, with eumelanin producing shades from brown to black, and pheomelanin contributing to red and blonde hues. The absence of melanin, whether due to genetic conditions such as albinism or the natural decline with age, leads to lighter or gray hair. In the eyes, melanin within the iris determines color, with high levels creating brown eyes, moderate levels producing green or hazel, and low levels resulting in blue eyes. Thus, melanin influences much of human appearance, shaping features that are deeply personal yet also universal in their biological basis. Beyond appearance, melanin plays roles in health that extend beyond its protective barrier against ultraviolet radiation. Its presence within certain cells of the inner ear contributes to hearing, and within the brain, it exists in specialized forms, thought to play protective roles in neurons. These functions are still being studied, but they suggest that melanin is not only a pigment of the skin, but a versatile substance with wide-reaching importance in the body. Pigmentation also carries social and cultural meaning. Throughout history, differences in skin color have been interpreted, celebrated, misunderstood, and misused. While biology explains pigmentation as an adaptation to sunlight, human societies have attached layers of meaning that extend beyond the scientific. Skin color has been used to create categories, to define identity, and at times, yet when viewed through the lens of biology, pigmentation tells a story of adaptation and resilience, a story of shared humanity, shaped by the sun, and written in the language of cells. Every shade of skin is evidence of the same fundamental process, the same pigment, the same protective adaptation, expressed in diverse and beautiful ways. The regulation of melanin production is influenced by both genetic and environmental factors. Genes determine the baseline activity of melanocytes, while hormones and signaling molecules influence their response. For example, melanocyte-stimulating hormone increases melanin synthesis, particularly after exposure to ultraviolet light. Certain conditions, such as pregnancy, can also alter pigmentation, leading to temporary darkening of areas such as the face or abdomen. Disorders of pigmentation reveal the importance of melanin, vitiligo, in which patches of skin lose their pigmentation due to immune attack on melanocytes. Albinism, in which melanin production is absent or reduced due to genetic mutations, and melasma, a condition of increased pigmentation, often associated with hormonal changes. Each of these conditions illustrates how vital and carefully regulated pigmentation is to the function of the skin. Pigmentation also reveals the interplay between health and environment. In places where sunlight is scarce, individuals with darker skin may be at greater risk of vitamin D deficiency if diet or lifestyle does not compensate for reduced synthesis. Conversely, individuals with lighter skin living in areas of intense sunlight may be at greater risk of sunburn or skin cancer. These interactions highlight the importance of understanding pigmentation not as a simple matter of appearance, but as a complex adaptation with consequences for health. Modern life, with its global migrations and varied lifestyles, often brings people into environments very different from those in which their ancestors evolved. In such contexts, awareness of pigmentation's biological role is vital for maintaining balance and well-being. To reflect on pigmentation and melanin is to reflect on the deep connection between the human body and the environment. The sun, distant and immense, leaves its imprint on the skin through the activity of microscopic cells and molecules. The spectrum of human skin tones, so varied and so meaningful, is a living map of adaptation to the light of the world. Beneath all of this variation lies a single pigment, melanin, serving as shield, as signal, as silent partner in health and identity. It reminds us that diversity is not a separation but a shared story, one written by the same biological processes expressed in countless ways. As we continue our calm journey through the integumentary system, attention will turn next to hair, another extension of the skin, where keratin and melanin combine to create strands that protect, regulate, and express. For now, pigmentation stands as both biology and poetry, a quiet blending of protection and beauty, a record of the sun, written upon the surface of the body. 11. Hair. Hair, though often thought of as ornamental or expressive, is in fact a vital component of the integumentary system, extending the functions of the skin in unique ways. Each strand of hair is a thread of keratin, produced within the depths of the dermis and emerging gracefully through the surface of the skin. It may seem delicate, yet it is remarkably strong, capable of resisting breakage and enduring the constant wear of daily life. Hair protects, insulates, and communicates, It is a marker of individuality and identity, yet at its core, hair is a biological structure, shaped by the same principles that govern the rest of the skin. Its presence across the human body tells a story of evolution, function, and quiet service. Every hair begins its life within a follicle, a small tubular structure that extends downward from the epidermis into the dermis, and sometimes even into the hypodermis. At the base of the follicle lies the hair bulb, a rounded structure surrounding the dermal papilla, which is rich in blood vessels. These vessels supply nutrients and oxygen to the rapidly dividing cells of the matrix, the living part of the follicle where hair growth originates. As these cells divide, older ones are pushed upward, gradually filling with keratin and hardening into the shaft of the hair. By the time the shaft emerges at the surface of the skin, the cells are no longer living but are tightly packed with keratin, forming the strong filament that we see and feel. The shaft of the hair is composed of 3 layers. At the center lies the medulla, a soft core present in some hairs but absent in others, depending on thickness. Surrounding this is the cortex, the main structural component, filled with keratin fibers arranged in parallel bundles. It is in the cortex that melanin granules are stored, giving hair its color. The outermost layer is the cuticle, composed of overlapping scales that protect the inner layers and give hair its smooth surface. The arrangement of these scales can influence the texture of hair, affecting how it reflects light and how it interacts with moisture and styling. Together, these layers create a structure that is both flexible and resilient, able to bend without breaking while maintaining strength across its length. Hair growth occurs in cycles, a rhythm of activity and rest that repeats throughout life. The first phase, known as anagen, is the active growth period, during which cells in the matrix divide rapidly and the hair shaft extends steadily. This phase can last for years, particularly in scalp hair, allowing strands to grow long. Following this is the catagen phase, a brief transitional period in which growth slows and the follicle begins to shrink. Finally, the telogen phase arrives, a resting period during which the hair remains anchored but no longer grows. Eventually, the old hair is shed, and a new one begins to form as the cycle repeats. At any given time, different hairs are in different phases, ensuring that shedding is gradual rather than sudden. The balance of these phases determines the density and length of hair, with variations influenced by genetics, hormones, and overall health. The color of hair, like that of the skin, is determined by melanin. Eumelanin produces shades ranging from brown to black, while pheomelanin imparts red and yellow tones. The combination and concentration of these pigments create the wide spectrum of human hair colors. Over time, the activity of melanocytes within the follicle declines, leading to a reduction in pigment. This results in gray or white hair, a natural marker of aging that reflects the gradual loss of melanin production. Just as skin pigmentation is an adaptation to sunlight, hair color carries with it traces of ancestry and genetics, a visible sign of the complex interplay between biology and identity. The distribution of hair across the human body reflects both evolutionary history and functional need. In early ancestors, a dense covering of hair provided warmth and protection, much as it does in other mammals today. Over time, human hair became finer and less dense, leaving only certain regions with prominent growth. The scalp retains thick hair, which protects the head from the sun and provides insulation against heat loss. Eyelashes and eyebrows protect the eyes from dust, debris, and sweat. Hair within the nostrils and ears helps filter particles from the air. The body as a whole is covered in fine vellus hair, nearly invisible but still contributing to sensory awareness, as even the lightest movement of air or contact with a surface can bend these hairs and stimulate nerve endings in the follicles. Hair is closely connected to sensation. for each follicle is surrounded by a network of nerve endings that respond when the hair is moved. This sensitivity allows hair to act as an early warning system, alerting us to the presence of small insects or subtle changes in the environment. A single hair on the arm, when displaced, can trigger awareness of a breeze or a touch, extending the sensory capacity of the skin beyond its surface. In this way, hair acts as an amplifier of sensation, increasing the range and refinement of the skin's awareness. The functions of hair extend into the regulation of body temperature as well. While not as prominent in humans as in other animals, hair does contribute to insulation. On the scalp, thick hair helps conserve heat in cold conditions and protect against the direct rays of the sun in hot climates. In other regions, hair may trap air close to the body, enhancing insulation when the tiny muscles at the base of follicles contract to raise the hairs. This reflex, though more symbolic in humans, is part of the body's ancient responses to cold or emotional states, manifesting as goosebumps. Even if its role in insulation is reduced, the presence of hair remains part of the interconnected system of protection and regulation. Hair also carries deep social and cultural meaning. Across human societies, it has been used to express identity, status, belief, and beauty. Hairstyles, grooming practices, and adornment vary widely, yet in all cases, hair becomes more than biology. It becomes expression. While this cultural dimension is not strictly anatomical, it reminds us of how the integumentary system interacts with the human experience, shaping not only survival, but also communication and belonging. The strands of keratin produced by the follicles become symbols, carrying messages that extend beyond their biological function. The health of hair is closely tied to the health of the body. Nutritional deficiencies, hormonal imbalances, stress, and illness can all affect growth, texture, and strength. Changes in hair may provide clues to underlying conditions, much as changes in skin and nails reflect systemic health. For example, thinning hair may result from deficiencies in iron or protein, while sudden shedding can be linked to stress or hormonal shifts. Thus, hair is not only protective and expressive but also diagnostic, offering subtle signals about the state of the body within. To reflect upon hair is to see it not as a simple adornment but as a living extension of the skin, one that grows, protects, senses, and communicates. It is born deep within the follicle, nourished by blood vessels, pigmented by melanocytes, and shaped into strands that emerge into the world. It cycles through phases of growth and rest, adapting continually to the body's rhythms. It serves as shield and sensor, protector and amplifier, marker of age and identity. In its quiet persistence, hair reflects the same principles as the skin itself: renewal, adaptation, and connection. As the exploration of the integumentary system continues, attention will turn to nails, another keratin-based structure that, though small, plays an essential role in protection and function. For now, hair can be appreciated as both a functional necessity and a subtle expression, a thread of keratin woven into the fabric of life, growing silently and serving faithfully across the span of human existence. 12. Nails. Nails are small, thin structures that sit quietly at the tips of fingers and toes, yet their importance within the integumentary system is profound. Like hair, they are composed largely of keratin, a protein that provides strength and resilience. Unlike hair, however, nails are flat, plate-like formations that protect delicate tissues, assist in fine motor skills, and provide subtle but valuable information about the body's health. They may seem simple when compared to the vast expanse of the skin or the complexity of hair growth, but nails are an elegant example of how even the smallest structures can serve multiple roles in the balance of the human body. Each nail begins in a region called the nail matrix, located beneath the skin at the base of the nail. This matrix is the living part of the nail, a layer of rapidly dividing cells that produce keratin. As these cells multiply, older ones are pushed outward, gradually flattening, hardening, and forming the visible nail plate that extends over the fingertip. The portion of the matrix visible beneath the nail is called the lunula, a pale, crescent-shaped area often seen near the base of the nail. The rest of the matrix is hidden beneath the cuticle and the skin of the nail fold, working silently to generate new growth. Nails grow continuously throughout life, at an average rate of a few millimeters per month, though this rate varies with age, health, and even the specific finger or toe. Fingernails generally grow faster than toenails, and nails on the dominant hand may grow slightly more quickly due to increased blood flow and use. The nail plate, the visible portion of the nail, is composed of tightly packed keratinized cells. These cells are translucent, allowing the underlying blood vessels in the nail bed to impart a pinkish hue. The plate itself is strong yet flexible, able to withstand pressure while still bending slightly to prevent breaking. Its smooth surface and curved shape provide both protection and function, shielding the sensitive tips of fingers and toes from injury, while also enhancing the ability to grasp and manipulate objects. Without nails, the fingertips would be more vulnerable to trauma, and the precision of many everyday tasks would be diminished. Beneath the nail plate lies the nail bed, a layer of skin rich in blood vessels and nerves. The close adherence of the plate to the bed ensures that the nail remains firmly attached and provides the characteristic pink color of healthy nails. At the base of the nail, the cuticle acts as a protective seal, guarding the space between the nail and the surrounding skin against infection. The edges of the nail are held in place by lateral folds of skin, framing the plate and guiding its growth. At the very tip, the free edge of the nail extends beyond the fingertip, gradually wearing down or being trimmed as it lengthens. The functions of nails extend beyond simple protection. They act as tools, enhancing the sensitivity and dexterity of the fingers. By pressing against the underside of the nail, the soft tissue of the fingertip gains a counterforce that increases tactile precision. This is why tasks such as picking up small objects, scratching an itch, or feeling fine textures are easier with nails. They also aid in defense and grooming, serving purposes that reach beyond the purely functional. The presence of nails allows for subtle manipulations that define many human activities, from writing to playing musical instruments to working with intricate tools. Nails also serve as indicators of health, reflecting changes within the body through alterations in appearance. A healthy nail is typically smooth, slightly curved, and uniform in color, with a consistent growth rate. However, deficiencies, illnesses, and systemic conditions can all leave their mark upon the nail. Pale nails may indicate anemia, while yellowish nails can signal respiratory issues or fungal infections. Bluish discoloration may suggest poor circulation or low oxygen levels. Pitting, ridging, or unusual thickening may reflect nutritional deficiencies, autoimmune conditions, or chronic diseases. Because nails grow slowly, changes may persist for months, providing a record of health that extends back in time. For this reason, physicians often examine nails as part of a physical assessment, recognizing them as subtle windows into the body's inner state. The growth and condition of nails are influenced by many factors. Nutrition plays a critical role, as proteins, vitamins, and minerals are essential for the continuous production of keratin. Biotin, AB vitamin, is particularly associated with nail health, supporting strength and growth. Iron, zinc, and calcium also contribute to the resilience of nails. Hydration is equally important, as excessive dryness can lead to brittleness and splitting. Age affects nail growth as well, with younger individuals generally experiencing faster growth, while older individuals may notice slower growth and increased fragility. Hormones, too, play a role, with pregnancy often accelerating nail growth due to increased circulation and metabolic activity. Culturally and socially, nails have taken on meaning beyond biology. Across human history, they have been shaped, decorated, and adorned as expressions of identity, status, and beauty. From the simple grooming of trimming and cleaning to elaborate practices of painting, polishing, and shaping, nails have been a canvas for human creativity. In some cultures, long nails have been symbols of wealth or leisure, suggesting that the individual did not engage in manual labor. In others, the health and cleanliness of nails have been associated with discipline and refinement. Though these meanings vary across societies, they remind us that the integumentary system is not only biological, but also deeply tied to human culture and expression. Nails also play a role in the body's defense mechanisms. When scratching, nails can help remove irritants, such as insects or debris from the skin. They can also serve as tools in protection or survival, capable of inflicting minor injury when needed. Though this function is less emphasized in modern life, it remains a reminder of the evolutionary versatility of nails as extensions of the integumentary system. The resilience of nails is balanced by their vulnerability. Because they are constantly exposed, nails are prone to injury, infection, and wear. Splits, cracks, and fungal growths are common, particularly in toenails, which endure pressure from shoes and repeated trauma from walking and running. Despite these challenges, nails regenerate steadily, with even severely damaged nails often capable of regrowth given time. This regenerative capacity reflects the same principle seen throughout the integumentary system: the quiet persistence of renewal, the continual effort to restore integrity and function. To reflect upon nails is to see them not as trivial details but as essential components of the human body. They protect the most sensitive parts of the hands and feet, enhance dexterity, provide clues to health, and serve as subtle tools for interaction with the world. They grow continuously, maintained by the hidden activity of the nail matrix, and they bear the record of both daily life and deeper conditions within the body. In their strength, they guard. In their flexibility, they adapt. In their appearance, they communicate. Nails, like hair and skin, are part of the living fabric that surrounds and sustains us. Simple in form, yet profound in function. As this calm journey through the integumentary system continues, attention will turn to the glands of the skin, structures that secrete sweat and oil, each playing their own quiet role in protection, regulation, and balance. For now, the nails stand revealed as small but mighty, modest in size yet essential in service, a reminder that even the smallest details of the human body carry significance far beyond what first meets the eye. 13. Glands of the skin. The skin, as the largest organ of the body, is not merely a protective covering or a sensory surface. It is also a living environment filled with specialized structures that contribute to its many functions. Among the most important of these structures are the glands, small but vital units that secrete substances essential for balance and survival. Though they are microscopic and often unnoticed, the glands of the skin serve as quiet regulators, producing sweat to cool the body, oil to maintain moisture, and subtle secretions that influence health, protection, and even social interaction. To reflect on the glands is to see how the integumentary system is not a passive shield, but a dynamic organ, constantly releasing and adjusting in harmony with the body's needs. The most widespread glands of the skin are the sweat glands, or sudoriferous glands, which exist in two main types: eccrine, and apocrine. Eccrine glands are found almost everywhere on the body, particularly numerous on the palms of the hands, the soles of the feet, and the forehead. These glands are coiled tubes embedded in the dermis, with ducts that open directly to the surface. Their function is both simple and profound. They produce sweat, a clear, watery fluid composed primarily of water, salts, and small amounts of metabolic waste. As this fluid spreads across the skin and evaporates, it carries heat away, cooling the body. This process is one of the body's most efficient mechanisms for temperature regulation, preventing overheating during exertion or in hot environments. Beyond cooling, eccrine sweat also plays a role in excretion, helping eliminate substances such as urea and ammonia. Though these wastes are present in small amounts, their removal contributes quietly to the body's balance. Apocrine glands, by contrast, are located mainly in specific regions, such as the armpits, groin, and around the nipples. These glands are larger than eccrine glands and open not directly onto the surface but into hair follicles. Their secretions are thicker, containing not only water and salts but also proteins and lipids. When released, these secretions are odorless, but once broken down by bacteria on the skin surface, they produce distinctive scents. This is the origin of body odor, a phenomenon that, though often viewed as undesirable in modern life, once played roles in communication and social interaction. In many animals, similar glands serve as scent markers, conveying identity, territory, or readiness for mating. In humans, apocrine secretions may still carry subtle signals, though their role has been diminished by cultural practices of hygiene and grooming. Regardless, they remain an integral part of the skin's physiology, their activity beginning at puberty and often influenced by hormones and emotional states. Another essential gland of the skin is the sebaceous gland, which produces sebum, an oily substance that coats both skin and hair. Sebaceous glands are usually found in association with hair follicles, releasing their oily secretion into the follicle, from which it spreads to the surface. Sebum plays a crucial role in maintaining the skin's flexibility and moisture, preventing it from drying and cracking. It also creates a barrier against water loss, ensuring that the skin retains the hydration needed for its function. In addition, sebum contributes to the acid mantle, a thin protective film that discourages the growth of harmful microbes. This subtle chemical shield is a quiet but powerful defense, allowing the skin to remain supple while reducing the risk of infection. Sebaceous gland activity varies across the body and throughout life. They are most concentrated on the scalp, face, and upper torso, regions where oil production is especially active. During puberty, under the influence of hormones, sebaceous glands enlarge and increase their secretion, often leading to oily skin and acne when ducts become blocked. In later life, their activity may diminish, leading to drier skin. Thus, the state of the sebaceous glands reflects both age and hormonal balance, a reminder of the skin's connection to the internal rhythms of the body. In addition to sweat and sebaceous glands, the skin also contains specialized glands with unique roles. Ceruminous glands, located in the ear canals, produce cerumen, commonly known as earwax. Though often regarded as a nuisance, cerumen has important protective functions. It traps dust, debris, and microorganisms, preventing them from reaching the delicate structures of the inner ear. Its slightly acidic and sticky nature discourages bacterial and fungal growth, while its slow movement outward helps clean the ear naturally. In this way, ceruminous glands provide a form of self-maintenance, keeping the ear canal clear and protected without the need for conscious effort. Mammary glands, though highly specialized and present in significant form only in females, are also considered modified glands of the integumentary system. Their primary function is the production of milk, a substance uniquely adapted to nourish infants in the early stages of life. Composed of fats, proteins, sugars, and immune factors, milk is more than food. It is a living fluid that supports growth, development, and immunity. The mammary glands are a striking example of how the skin and its derivatives have evolved to meet the needs of survival, extending the role of secretion beyond protection and regulation into nourishment and care. The activity of skin glands is not random but regulated by the nervous and endocrine systems. Eccrine glands, for example, are controlled by the sympathetic nervous system, responding to both temperature changes and emotional states. This is why stress or anxiety can trigger sweating even in the absence of heat. Apocrine glands are influenced by hormones, their activity increasing at puberty, and often fluctuating with cycles of stress or emotion. Sebaceous glands, too, respond strongly to hormones, particularly androgens, which stimulate their growth and activity. These interactions illustrate the close connection between the integumentary system and the broader physiology of the body, a constant dialogue between inner signals and outer responses. The glands of the skin also reveal the delicate balance between protection and vulnerability. When functioning normally, they maintain moisture, regulate temperature, excrete wastes, and defend against microbes. Yet when disrupted, they can contribute to disorders. Overactive sebaceous glands may lead to acne, while underactive ones contribute to dryness. Blocked sweat glands can cause heat rash, while excessive sweating may lead to discomfort and imbalance. Infections of sweat or oil glands may produce localized swelling or inflammation. These conditions remind us of the importance of glands in daily comfort and health, and how even small disturbances can affect the harmony of the body. To reflect on the glands of the skin is to see the integumentary system not as a static surface, but as a living landscape of secretions and balances. Sweat cools, oil protects, earwax defends, milk nourishes. Each gland, though small, contributes to the whole, performing its role in silence, releasing its product in measured amounts, adjusting moment by moment to the needs of the body. These secretions may seem ordinary, unnoticed in daily life, but they are part of the unbroken rhythm that keeps the body balanced, defended, and sustained. As we continue our calm journey through the integumentary system, the focus will turn next to the relationship between skin and vitamin D, a vital link that connects the integumentary system to the nourishment and strength of the entire body. For now, the glands of the skin can be seen as quiet caretakers, hidden within the dermis, working steadily and without pause, secreting the subtle fluids that protect, balance, and maintain life. 14. Skin and vitamin D. The skin, though often thought of as a surface barrier and sensory organ, plays yet another vital role that reaches deep into the chemistry of life. It is the place where vitamin D begins its journey. This connection between sunlight, skin, and health is one of the most profound examples of how the human body is linked to the natural world. Vitamin D is not a nutrient obtained solely from food, though diet can contribute. It is also synthesized within the body, and the skin is the gateway for this process. Without the skin's ability to initiate the production of vitamin D, bones would weaken, calcium balance would falter, and many systems of the body would be compromised. The story of skin and vitamin D is the story of light becoming nourishment, of the sun's rays transformed into a substance that sustains life. The process begins when the skin is exposed to ultraviolet B radiation from sunlight. Within the epidermis lies a molecule known as 7-dehydrocholesterol, a compound derived from cholesterol. When struck by ultraviolet B photons, this molecule undergoes a transformation, breaking open its chemical structure and forming provitamin D3. This is not yet the active vitamin, but an essential precursor. Over the course of hours, previtamin D3 is gradually converted by heat into vitamin D3, also called cholecalciferol. From the skin, this molecule enters the bloodstream, where it travels to the liver and kidneys for further modification. In these organs, enzymes convert it first into calcidiol and then into calcitriol, the active form of vitamin D that can act throughout the body. Thus, the skin is the first stage of a pathway that extends from sunlight to cellular function, a bridge between the external environment and the deepest levels of human physiology. The importance of vitamin D cannot be overstated. Its most well-known role is in the regulation of calcium and phosphorus, minerals essential for the formation and maintenance of bones. Without sufficient vitamin D, the body cannot absorb calcium efficiently from the diet, leading to weakened bones, a condition known as rickets in children and osteomalacia in adults. Over time, this deficiency can also contribute to osteoporosis, where bones become fragile and prone to fracture. The skin's ability to initiate vitamin D production is therefore directly tied to the strength of the skeleton, the very framework of the body. Beyond bones, vitamin D influences many other systems. It plays roles in immune regulation, supporting the body's defense against infection. It contributes to muscle strength and coordination, helping maintain balance and reducing the risk of falls. It has been studied for its influence on mood and mental health, with low levels associated with seasonal affective disorder and other mood disturbances. Though research continues to reveal new aspects of vitamin D's influence, what remains constant is the skin's central role in producing it. The rays of the sun, captured by a molecule in the epidermis, set in motion processes that ripple throughout the body. The balance of vitamin D production is delicate, shaped by factors of geography, lifestyle, and biology. In regions near the equator, sunlight is abundant year-round, and small amounts of exposure can provide sufficient vitamin D. In higher latitudes, particularly during winter, ultraviolet B radiation may be too weak to trigger synthesis, leaving individuals dependent on dietary sources or stored reserves. Skin pigmentation also plays a role. Melanin, the pigment that protects against ultraviolet damage, also reduces the penetration of ultraviolet B rays. Individuals with darker skin require more sunlight exposure to produce the same amount of vitamin D as those with lighter skin. This balance reflects once again the adaptation of pigmentation to environment, protection in regions of high sun exposure, efficiency in regions with less. Modern life, with its indoor living, clothing, and use of sunscreens, also influences vitamin D production, often reducing the skin's opportunity to interact with sunlight. The regulation of vitamin D synthesis is naturally self-limiting. Prolonged exposure to sunlight does not lead to toxic levels, for excess provitamin D3 and vitamin D3 are degraded into inactive forms. This safeguard prevents overproduction, allowing the body to balance between sufficiency and safety. The risk of deficiency, however, is more common, especially in environments where sunlight is scarce or where lifestyle reduces exposure. In such cases, dietary intake from sources such as fatty fish, fortified foods, or supplements becomes important, complementing the skin's natural ability to produce the vitamin. The connection between skin and vitamin D also highlights the interplay between health and the environment. The sun, a distant star, sends photons across space, and when they touch the skin, they are transformed into molecules that influence bones, muscles, and immunity. This is a reminder that human beings are not isolated but part of a larger system, dependent upon natural forces for sustenance. The warmth felt on the skin during a sunny day is more than comfort. It is a signal that life itself is being nourished at a molecular level. At the same time, the relationship with sunlight carries risks. For the same ultraviolet rays that initiate vitamin D production can also damage DNA and accelerate aging. The skin balances this paradox through pigmentation and repair mechanisms, seeking to capture the benefits of light while minimizing its harm. Sunscreens and protective clothing, while reducing risk, also reduce vitamin D synthesis, requiring thoughtful balance in modern life. Too little exposure can lead to deficiency, while too much can cause injury. Thus, the skin once again demonstrates its role as a mediator, managing the interface between body and environment, between necessity and danger. In childhood, the importance of vitamin D is especially pronounced, for bones are growing and forming their strength for a lifetime. In adulthood, it remains vital to maintain bone density and prevent loss. In older age, sufficient vitamin D helps preserve mobility, strength, and resilience. Across all stages of life, the skin's contribution to this process remains constant, though circumstances may alter how much sunlight or supplementation is needed. It is a thread of continuity, linking the first days of infancy to the final years of life, a quiet partnership between skin and sun that sustains the body across time. To reflect on the skin's role in vitamin D is to see it as more than a surface or a covering. It is a biochemical organ, capable of transforming light into nourishment. It is a reminder that health is not only internal but also shaped by the environment, by the rhythms of day and season, by the interplay of light and life. In every moment of sunlight upon the skin, this process unfolds, invisible yet profound, sustaining the skeleton, strengthening immunity, and influencing the course of human well-being. As we continue the calm exploration of the integumentary system, attention will turn next to the skin's role in immunity, its silent watch against invaders, and its constant vigilance as part of the body's defense. For now, the story of skin and vitamin D stands as one of the most beautiful examples of biology's harmony with the natural world, where light becomes strength, and the surface of the body becomes the entry point for one of life's most essential substances. 15. The skin and the immune system. The skin is often described as the body's first line of defense, and nowhere is this more apparent than in its role as part of the immune system. While it may appear to be a simple covering, the skin is in fact a living fortress, equipped with barriers, cells, and mechanisms designed to identify, repel, and neutralize threats. Every moment of life, the skin encounters countless potential invaders: bacteria, viruses, fungi, parasites, and harmful chemicals. Yet most of these are prevented from ever reaching deeper tissues. The immune role of the skin is not passive but active, involving both physical barriers and cellular defenses that work together to maintain balance and protect the body from harm. The first layer of defense is mechanical. The epidermis, with its tightly packed keratinized cells, forms a shield that is difficult for pathogens to penetrate. The stratum corneum, composed of dead but resilient cells bound by lipids, is both a wall and a seal, preventing microbes from slipping between cells or gaining access to the living tissues below. This barrier is continually renewed, with old cells shed and replaced by new ones, ensuring that even if pathogens attach to the surface, they are carried away in the silent shedding of skin. The waterproof nature of the epidermis also denies microbes the moisture many of them require to thrive, making the surface of the body an inhospitable environment for most invaders. Complementing this physical barrier is a chemical defense system. The surface of the skin is slightly acidic, with a pH around 5, due to the secretions of sweat and sebum. This acidic film, known as the acid mantle, discourages the growth of harmful bacteria and fungi, while still allowing the survival of beneficial microbes that form part of the skin's natural flora. Sweat also contains antimicrobial peptides, small proteins that can disrupt the membranes of bacteria and inhibit their growth. Sebum, the oily secretion of sebaceous glands, helps form a protective film that traps particles and provides additional antimicrobial activity. These secretions, though subtle and unnoticed in daily life, are part of a sophisticated chemical shield that enhances the immune function of the skin. Within the epidermis itself are specialized immune cells that act as sentinels. Chief among these are the Langerhans cells, a type of dendritic cell that continuously patrols the surface layers. These cells are adept at recognizing foreign substances, capturing them, and presenting fragments to other immune cells. When they encounter a potential invader, they migrate to nearby lymph nodes, where they activate T cells and initiate a broader immune response. In this way, the skin is not only a barrier but also an early warning system, capable of detecting threats and alerting the body's defenses long before infection takes hold. The dermis, lying just beneath the epidermis, is home to additional immune activity. Here, macrophages and mast cells reside, ready to respond to injury or invasion. Macrophages engulf and destroy pathogens, clearing debris and orchestrating the immune response by releasing signaling molecules. Mast cells, meanwhile, release histamine and other mediators that increase blood flow and attract immune cells to the site of danger. This response, though often experienced as redness, swelling, or itching, is part of the skin's protective mechanism, a rapid mobilization designed to isolate and eliminate threats before they can spread deeper. One of the most fascinating aspects of the skin's immune role is its relationship with the microbiome. The skin is home to trillions of microorganisms, including bacteria, fungi, and viruses, that live harmlessly or even beneficially on its surface. Far from being mere bystanders, these microbes form a vital part of the skin's defense. They compete with harmful organisms for space and nutrients, produce substances that inhibit pathogen growth, and interact with the immune system to fine-tune its responses. This partnership between the skin and its microbial inhabitants creates a balanced ecosystem, where the presence of friendly microbes strengthens the skin's ability to resist harmful ones. Disruptions to this balance, such as through overuse of harsh chemicals or antibiotics, can weaken defenses and lead to problems like infections or inflammation. The skin's immune system is also deeply involved in the process of wound healing. When the barrier is breached, the immune response is immediate. Platelets form clots to seal the wound, while immune cells flood the area to destroy invaders and clear damaged tissue. Inflammation, often seen as swelling and redness, is a sign of this immune activity, an effort to isolate the injury and prepare the way for repair. As healing progresses, immune cells release signals that attract fibroblasts, which build new collagen to close the wound. Eventually, the epidermis renews itself, restoring the barrier and returning the skin to its protective role. This ability to repair while defending is one of the most remarkable features of the skin, a testament to its resilience and adaptability. The immune role of the skin extends beyond immediate defense to the creation of memory. When the skin encounters a pathogen, the immune system not only responds but also remembers. T cells and B cells, once activated, retain a record of the invader, enabling a faster and stronger response if the same pathogen is encountered again. This is the basis of immunity, and the skin plays an essential part in establishing it. Vaccinations administered through the skin take advantage of this capability, using the skin's immune cells to introduce harmless fragments of pathogens and train the body to defend against them in the future. Yet, as with all systems, balance is crucial. When the skin's immune responses are too strong or misdirected, they can lead to problems. In conditions such as eczema, psoriasis, or allergic dermatitis, the immune system overreacts to harmless triggers, causing inflammation, itching, and discomfort. These conditions illustrate that while the skin's defenses are powerful, they must also be carefully regulated to avoid harming the very body they are meant to protect. The skin, then, is not simply a fortress but a finely tuned system, balancing vigilance with restraint, defense with tolerance. The immune functions of the skin reveal its role as both shield and communicator. It stands at the boundary of the body, constantly sampling the environment, interacting with microbes, responding to injury, and signaling the deeper immune system. It is not isolated but integrated, part of a vast network of defenses that extend throughout the body. In its silence, it protects. In its vigilance, it sustains life. To reflect on the skin's role in immunity is to see it as more than an organ of touch or appearance. It is a sentinel, a guardian that stands watch over the body's frontier. It repels invaders, supports allies, repairs itself when breached, and remembers past battles to prepare for future ones. It is a living shield that never rests, one that serves without demand, its activity hidden yet essential. As this calm journey through the integumentary system continues, attention will turn next to how the skin and its structures change over time across the span of human life. From the softness of infancy to the weathered texture of age, the integumentary system evolves, carrying the marks of growth, adaptation, and time itself. For now, the skin, as part of the immune system, stands revealed as a guardian and healer, silent in its watch, yet tireless in its service. 16. The integumentary system. Across the lifespan, the integumentary system, like every other system of the human body, does not remain static. From the first moments of life to the final years, it changes in appearance, structure, and function, reflecting both the passage of time and the influence of environment and experience. The skin, hair, and nails carry the imprint of growth, development, and aging, serving not only as protectors and regulators, but also as storytellers of the human journey. To trace the integumentary system across the lifespan is to witness how it adapts to the needs of each stage of life, how it responds to challenges, and how it bears the quiet record of time. At birth, the skin of a newborn is soft, delicate, and highly sensitive. It has completed its development within the protective environment of the womb, and now it encounters the air for the first time. The outermost layer of the epidermis, though thin, is already functional, providing a barrier against dehydration and infection. Many newborns are covered at birth with vernix caseosa, a creamy substance composed of sebum and shed skin cells that protected the fetus in utero and continues to provide a protective layer in the first hours after birth. The skin of infants is more permeable than that of adults, making it more vulnerable to irritation but also more capable of rapid healing. Its sensitivity to touch is profound, with receptors ready to transmit the comfort of contact, an essential component of bonding and development. As childhood progresses, the integumentary system grows and strengthens along with the body. The skin becomes more resilient, better able to withstand environmental exposure. Hair grows more thickly on the scalp, while fine vellus hair covers much of the body. Nails lengthen and strengthen as the matrix becomes more active. During these years, the skin remains smooth and elastic, with abundant collagen and elastin supporting growth and flexibility. Injuries tend to heal quickly, and scars may fade more completely than in later life. The integumentary system in childhood is marked by renewal, by resilience, and by a readiness to adapt to a rapidly changing body. With the onset of adolescence, the integumentary system undergoes profound changes under the influence of hormones. Sebaceous glands become more active, increasing the production of sebum. This surge often leads to oily skin and acne, a common condition of teenage years. Sweat glands, particularly apocrine glands, also become active at puberty, leading to stronger body odor as secretions interact with skin bacteria. Hair begins to grow more prominently in new regions, such as the face, underarms, and groin, reflecting the influence of androgens. The scalp hair may become thicker or oilier, and the distribution of hair takes on patterns associated with sex and maturity. The skin itself becomes more resilient in some ways, but also more prone to inflammation due to hormonal fluctuations. The changes of adolescence are not only physical, but also social. For the integumentary system becomes a visible marker of maturity, identity, and self-expression. In adulthood, the integumentary system generally reaches its peak of function. The skin is strong and resilient, its barrier intact, its ability to regulate temperature and sensation at full capacity. Hair and nails grow steadily, and the glands of the skin maintain a balance of oil and sweat production that supports protection and comfort. This stage of life often reflects lifestyle, with the skin showing the effects of nutrition, sleep, stress, and environmental exposure. Sunlight, in particular, leaves its imprint over time, with pigmentation changes, freckles, or early wrinkles appearing depending on protection and genetics. The integumentary system in adulthood is both steady and dynamic, serving faithfully while quietly recording the influence of habits and surroundings. As the decades pass, the signs of aging begin to appear, particularly within the skin. The dermis gradually loses collagen and elastin, leading to reduced strength and elasticity. The skin becomes thinner, less supple, and more prone to wrinkles and sagging. The production of sebum decreases, leading to dryness. Sweat glands become less efficient, diminishing the ability to regulate temperature effectively. The renewal of the epidermis slows, meaning wounds take longer to heal, and the skin becomes more vulnerable to injury. Pigmentation changes, such as age spots, emerge as a record of sun exposure. The blood vessels of the dermis may become more fragile, leading to bruising. Nails grow more slowly and may become thicker or more brittle, while hair may thin or lose its pigment, turning gray or white. These changes are natural, reflecting the gradual decline of cellular function and renewal. Despite these shifts, the integumentary system remains resilient. Even in older age, it continues to protect, to regulate, and to sense. It may not do so with the same efficiency as in youth, but its functions remain essential. The skin of the elderly still shields against infection, though with reduced immunity. It still participates in vitamin D synthesis, though with less efficiency. It still conveys sensation, though sometimes with diminished sensitivity. Hair, even as it thins, continues to serve as a marker of identity. Nails, even as they change, continue to protect the fingertips and toes. The integumentary system across the lifespan demonstrates both the inevitability of change and the persistence of function. The story of the integumentary system is also the story of memory. Lines and wrinkles trace the passage of years, expressions repeated countless times until they become etched in the skin. Freckles mark moments of sunlight, and gray hair signals the progression of time. The integumentary system does not merely serve the body, it records its history. In this way, the skin, hair, and nails are both guardians and storytellers, bearing silent witness to the journey from birth to age. Throughout the lifespan, care for the integumentary system remains important. In infancy, protection from irritation and infection is crucial. In childhood and adolescence, hygiene and balanced care support the skin through its changes. In adulthood, protection from the sun and maintenance of hydration preserve strength. In older age, gentle care, moisturization, and attention to nutrition help maintain resilience. Though its appearance changes, the integumentary system continues to reflect the body's overall state of health and well-being. To reflect upon the integumentary system across the lifespan is to see the unity of change and continuity. From the soft skin of a newborn to the lined face of old age, it adapts, it adjusts, it responds to the needs of the body at each stage. It protects the fragile, it supports the growing, it records the mature, and it endures with the aged. It is both constant and changing, both surface and depth, both shield and story. As this calm exploration continues, attention will turn to the relationship between the integumentary system and other organ systems. For the skin does not act alone but works in concert with the body as a whole. For now, the journey across the lifespan reminds us that the integumentary system is a companion for life itself, beginning with our first breath and continuing until our last, a quiet witness to the passage of time and a faithful servant through every stage of existence. 17. The integumentary system and its connections to other organ systems. The integumentary system, though distinct in its structure and functions, does not act alone. Like every system in the human body, it is interwoven with others, forming an intricate web of interactions that sustains life. The skin, hair, nails, and glands do not merely serve their individual purposes. They collaborate with the nervous system, the circulatory system, the endocrine system, the skeletal system, the immune system, and many others. To study the integumentary system in isolation is to see only part of its story, for its true significance lies in its connections, in the way it integrates with the body as a whole. These connections are silent yet constant, occurring at every moment, ensuring that the body is not a collection of parts, but a living, unified whole. One of the most immediate connections is with the nervous system. The skin is filled with sensory receptors, specialized nerve endings that allow us to feel touch, pressure, temperature, vibration, and pain. These signals are transmitted through peripheral nerves to the spinal cord and brain, where they are interpreted and integrated. Without the nervous system, the skin would be mute, unable to communicate the countless sensations that shape our experience of the world. Conversely, without the skin, the nervous system would lack one of its richest sources of input. This partnership makes the integumentary system a sensory organ in its own right, a vast and sensitive interface between the body and the environment. The circulatory system is equally essential to the skin. Blood vessels within the dermis provide the nutrients and oxygen that sustain the epidermis, which has no blood supply of its own. These vessels also remove waste products, maintaining the health of the skin's cells. Beyond nourishment, the circulatory system works closely with the skin to regulate temperature. By dilating and constricting vessels in the dermis, the circulatory system, guided by signals from the nervous system, adjusts heat exchange with the environment. Blood flow to the skin is increased when the body needs to release heat, as in exercise or warm conditions, and reduced when conserving heat is necessary, as in cold environments. This interplay demonstrates how the integumentary system and the circulatory system function as partners in homeostasis. The endocrine system, which governs hormones, also interacts deeply with the integumentary system. Hormones regulate sebaceous gland activity, sweat production, hair growth, and pigmentation. During puberty, rising levels of androgens increase sebum production, often leading to oily skin and acne. Estrogen influences skin thickness, elasticity, and hydration, while cortisol, the stress hormone, can affect skin health and healing. The production of melanin in response to sunlight is mediated by melanocyte-stimulating hormone, linking pigmentation to hormonal regulation. Even vitamin D, which the skin begins to synthesize, is part of the endocrine system once it is activated and released into circulation to act on distant organs. The integumentary system, then, is not only shaped by hormones but also contributes to endocrine function, making this relationship reciprocal and profound. The skeletal system also depends on the integumentary system, though the connection may seem less obvious. The skin, through its role in vitamin D synthesis, directly influences the absorption of calcium and phosphorus from the diet. These minerals are essential for bone growth, maintenance, and repair. Without adequate vitamin D, bones become weak and prone to deformities or fractures. Thus, the integumentary system, by capturing sunlight and beginning the transformation of 7-dehydrocholesterol into vitamin D, supports the strength of the skeleton. The skin and bones, though physically separated, are united in a metabolic partnership that underlies the body's structural stability. The immune system and the integumentary system are perhaps the most closely allied of all. The skin itself is an immune organ, containing cells that patrol, detect, and respond to threats. It forms a physical and chemical barrier that denies entry to pathogens, while its resident immune cells communicate with the broader immune network to mobilize defenses. The lymphatic vessels within the dermis connect the skin to the lymphatic system, ensuring that immune signals and cells can travel swiftly to and from sites of invasion. Vaccines delivered through the skin take advantage of this connection, stimulating immune responses more effectively by engaging the skin's abundant immune cells. This integration makes the skin not only a shield but also a gateway to the body's defense system. The respiratory system, though seemingly distant, also connects to the integumentary system. Both play roles in the exchange of gases, with the skin contributing in small ways to oxygen absorption and carbon dioxide release, particularly in thin or moist regions. More importantly, the skin and respiratory system both act as barriers to the environment, filtering and protecting against harmful substances. The hair in the nostrils, for example, helps trap dust and particles before they enter the airways, while the skin of the face and lips protects the delicate tissues of the mouth and nose. In conditions of intense exertion or heat, the respiratory and integumentary systems work together, with breathing and sweating both contributing to cooling the body and maintaining balance. The digestive system, too, is linked to the skin, though indirectly. The nutrients absorbed from food proteins, fats, vitamins, and minerals provide the raw materials for skin, hair, and nails. Deficiencies in diet often manifest first in the integumentary system, as seen in brittle nails, thinning hair, or dry, damaged skin. Conversely, the skin reflects the digestive system's success or struggle, serving as an external indicator of internal nourishment. The production of vitamin D in the skin also influences digestion, as it regulates the absorption of calcium and phosphorus from the intestines. Thus, the integumentary and digestive systems are partners in maintaining the nutritional foundation of the body. The urinary system also interacts with the integumentary system in maintaining fluid and electrolyte balance. While the kidneys are the primary regulators, the skin contributes through sweat. During exertion or heat, sweat glands release water and salts, helping to regulate internal chemistry. This process complements the work of the urinary system, demonstrating the body's layered approach to homeostasis. The two systems cooperate silently, one through filtering blood and excreting urine, the other through releasing sweat, both maintaining balance through different pathways. Even the reproductive system shares connections with the integumentary system. Hormones that govern reproduction also influence skin, hair, and nails. During pregnancy, changes in hormone levels often lead to increased pigmentation, faster nail growth, and shifts in hair texture or thickness. The mammary glands, specialized structures of the integumentary system, become active in females to provide nourishment for infants. In this way, the skin not only reflects reproductive changes, but also contributes directly to the survival of the next generation. All of these connections highlight the reality that the integumentary system is not separate but integrated, woven into the whole tapestry of human biology. It protects, senses, and regulates, but it also nourishes, communicates, and collaborates with every other system. Its health depends on the body, and the body depends on its health. The integumentary system is not merely a covering, but a partner, a collaborator that sustains life by linking the body to the environment and to itself. To reflect on these connections is to see the body as a unity, where no system stands alone and no function is isolated. The integumentary system is the frontier, the surface upon which life meets the world, but it is also the bridge that links the internal to the external, the visible to the invisible, the part to the whole. It speaks the language of sensation to the nervous system, the language of nourishment to the skeletal system, the language of balance to the circulatory and urinary systems, the language of protection to the immune system, and the language of care to the reproductive system. As this calm journey moves toward its conclusion, the next reflections will consider the integumentary system as a whole, its unity, its symbolism, and its quiet service across a lifetime. For now, it stands revealed not as an isolated organ system, but as a living thread that runs through the entire fabric of the body, connecting, supporting, and uniting all that makes life possible. 18. Disorders of the integumentary system. The integumentary system, despite its resilience and constant renewal, is not immune to disturbance. Its vast surface and constant exposure to the environment make it vulnerable to injury, infection, imbalance, and disease. Because the skin, hair, and nails are visible, disorders of this system are often noticed more readily than those of deeper organs, and they can carry both physical and emotional impact. Some disorders are temporary and minor, while others are chronic or life-threatening. To reflect on these conditions is not to dwell on distress, but to understand the delicate balance the integumentary system maintains and the consequences when that balance falters. The disorders of the integumentary system remind us of its importance, its fragility, and its need for care across the span of life. One of the most common disturbances is acne, a condition often associated with adolescence, but capable of affecting individuals at any age. Acne arises when sebaceous glands become overactive, producing excess sebum that, combined with dead skin cells, clogs hair follicles. Within these clogged follicles, bacteria may proliferate, leading to inflammation and the formation of pimples, blackheads, or cysts. Though often regarded as a cosmetic concern, acne is rooted in the biology of glands, hormones, and microbial balance. Its presence can affect self-esteem, particularly in youth, serving as a reminder of how visible the integumentary system is in social life. Treatment, whether through gentle cleansing, medications that regulate oil production, or antibiotics that address bacterial overgrowth, seeks to restore balance to this disrupted system. Another frequent condition is eczema, also known as atopic dermatitis. This disorder is characterized by inflammation, redness, itching, and dryness of the skin. Eczema arises from a combination of genetic, immune, and environmental factors, often reflecting a skin barrier that is less effective at retaining moisture and resisting irritants. It tends to appear in childhood but may persist or recur throughout life. The discomfort of eczema lies not only in its physical symptoms but also in the cycle of itch and scratch, where irritation leads to scratching that further damages the skin, perpetuating the condition. Moisturizers, anti-inflammatory creams, and avoidance of triggers are common strategies to soothe and manage this condition. Eczema highlights the importance of the skin's barrier role and the consequences when that barrier is compromised. Psoriasis is another disorder of the integumentary system, notable for its chronic nature and its striking appearance. In psoriasis, the cycle of skin cell renewal is accelerated dramatically, with cells rising to the surface in days rather than weeks. The result is thickened, scaly patches of skin that may be red, silvery, or inflamed. Psoriasis is now understood as an autoimmune condition, where the immune system mistakenly triggers excessive activity in the epidermis. Its impact extends beyond the skin, often involving joints in a condition known as psoriatic arthritis. Psoriasis is a reminder that the integumentary system is deeply connected to the immune system, and that disturbances in one may manifest in the other. Treatments range from topical therapies to systemic medications that modulate the immune response, each aimed at slowing the accelerated rhythm of skin renewal. Infections of the skin are common due to its role as a boundary between body and environment. Bacterial infections, such as impetigo or cellulitis, arise when pathogens breach the skin's barrier, often through small cuts or abrasions. Fungal infections, like athlete's foot or ringworm, thrive in warm, moist environments and take advantage of weakened or stressed skin. Viral infections, such as warts caused by the human papillomavirus, or cold sores caused by herpes simplex virus, reveal how microbes may establish themselves in skin cells. Each of these infections demonstrates the constant challenge faced by the skin in maintaining its defenses. While many are self-limited or treatable with medications, they highlight the need for the integumentary system to remain intact and vigilant. Skin cancer is among the most serious disorders of the integumentary system. It arises when cells of the skin undergo mutations that allow uncontrolled growth. The most common types are basal cell carcinoma, squamous cell carcinoma, and melanoma. Basal and squamous cell carcinomas, while generally less aggressive, can cause local damage if untreated. Melanoma, arising from melanocytes, is more dangerous, capable of spreading to other organs. The primary cause of skin cancer is excessive ultraviolet radiation from sunlight or artificial sources, which damages DNA in skin cells. The protective role of melanin reduces risk, but does not eliminate it. Early detection and treatment are critical, as outcomes improve significantly when cancers are identified in their early stages. Skin cancer underscores the importance of the skin's relationship with sunlight, balancing its necessity for vitamin D with the risks of overexposure. Hair disorders also reflect disturbances of the integumentary system. Alopecia, or hair loss, can occur for many reasons, including genetic predisposition, hormonal imbalance, autoimmune conditions, or stress. Androgenetic alopecia, often called male or female pattern baldness, is influenced by hormones and genetics, leading to progressive thinning of scalp hair. Alopecia areata, an autoimmune condition, results in sudden, patchy hair loss as the immune system attacks hair follicles. Though these conditions are not life-threatening, they can carry deep emotional and social effects, as hair is closely tied to identity and self-expression. Treatments, ranging from topical medications to hair transplantation, aim to restore or preserve hair growth, though outcomes vary. Nail disorders, though less common, also provide windows into systemic health. Fungal infections of the nails, known as onychomycosis, can cause thickening, discoloration, and brittleness. Trauma may lead to ridges or detachment of the nail plate. Systemic conditions, such as iron deficiency anemia, may produce spoon-shaped nails, while cyanosis from poor oxygenation may cause bluish discoloration. Because nails grow slowly, changes may persist for months, offering a long-term record of health disturbances. Their appearance and condition often provide subtle but valuable diagnostic clues. Burns represent another category of integumentary disorder arising from thermal, chemical, electrical, or radiation injury. Burns compromise the protective barrier of the skin, leading to fluid loss, vulnerability to infection, and disruption of temperature regulation. Their severity is classified by depth. First-degree burns involve only the epidermis. Second-degree burns extend into the dermis, and third-degree burns destroy the full thickness of skin. Severe burns can be life-threatening, not only due to loss of barrier function, but also because of systemic effects such as shock. Treatment requires careful management of fluids, infection control, and often surgical intervention, such as grafting. Burns highlight the essential nature of the skin's functions and the dramatic consequences when they are suddenly lost. There are also rare but significant genetic disorders of the integumentary system. Conditions such as albinism, in which melanin production is absent or reduced, leave the skin vulnerable to sunlight and impair vision. Epidermolysis bullosa, a group of disorders affecting proteins that anchor skin layers together, results in fragile skin that blisters easily. Though uncommon, these conditions demonstrate the importance of the skin's molecular architecture and how even small defects can have profound effects on life. The disorders of the integumentary system, from the common to the rare, from the mild to the severe, remind us of its complexity and centrality. They also remind us of its visibility. When the skin, hair, or nails are affected, the changes are often plain to see, shaping not only health, but also self-image and social interaction. The integumentary system is both shield and signal, and when disturbed, it communicates distress openly. To care for the integumentary system is to protect more than the surface. It is to sustain the body's balance, resilience, and integrity. As this calm exploration draws closer to its conclusion, the next reflection will turn to healing and resilience, to the ways in which the integumentary system recovers from injury and restores itself. For now, disorders of the integumentary system remind us of both its vulnerability and its strength, its constant exposure to the world, and its quiet, faithful service in defending life. 19. Healing and repair in the integumentary system. The integumentary system is remarkable not only for its ability to protect, regulate, and sense, but also for its capacity to heal. Few systems in the body are as constantly challenged as the skin. For every day it endures scrapes, cuts, pressure, and exposure. Yet, despite this unending wear, the skin is able to repair itself with quiet persistence. Healing is one of its most vital functions, a process that restores integrity, preserves balance, and allows life to continue uninterrupted. To understand healing and repair in the integumentary system is to see resilience at its most visible. The body's ability to recover and renew itself after harm. At the most basic level, the skin is always renewing. Even without injury, the epidermis undergoes a constant cycle of shedding and replacement. Keratinocytes are born in the basal layer, ascend through the strata, and eventually flatten into protective scales before being shed from the surface. This cycle, which takes a few weeks, ensures that minor damage to the outermost layer is constantly repaired without need for special intervention. It is an everyday form of healing, one so seamless that it passes unnoticed. The surface of the body is never static, but a flowing river of cells, replacing what is lost and maintaining the barrier against the world. When injury penetrates more deeply, however, the body initiates a more complex process of healing. This process can be understood as unfolding in stages, though in reality, these stages overlap and influence one another. The first stage is hemostasis, the immediate effort to stop bleeding when the skin is cut. Platelets in the blood adhere to the damaged vessel walls, releasing factors that trigger clotting. A network of fibrin forms, creating a temporary plug that not only halts blood loss but also seals the wound against entry of pathogens. This clot, which dries into a scab at the surface, is both shield and scaffold, protecting the wound while the deeper processes of healing begin. The second stage is inflammation, a response often visible as redness, warmth, swelling, and sometimes pain. Far from being harmful, inflammation is an essential step in healing. Blood vessels dilate, increasing blood flow to the injured area. Immune cells flood the wound, destroying microbes and clearing away dead tissue. Macrophages engulf debris, while neutrophils release enzymes to combat invaders. Chemical signals attract additional cells, coordinating a response that cleanses the wound and prepares it for repair. Though inflammation can be uncomfortable, it is a sign of the body's vigilance, its immediate recognition of injury, and its determination to protect against further harm. The third stage is proliferation, where new tissue begins to form. Fibroblasts, specialized cells within the dermis, migrate into the wound and begin producing collagen, the structural protein that provides strength and framework. Small blood vessels sprout and grow, restoring circulation to the damaged area in a process known as angiogenesis. Keratinocytes from the edges of the wound migrate across the surface, gradually covering the gap with new epidermis. This stage transforms the wound from an open vulnerability into a site of renewal, where the architecture of skin is gradually re-established. The scab above eventually loosens and falls away, revealing the new tissue beneath. The fourth stage is remodeling, or maturation, a process that may continue for weeks or even months. During this time, collagen fibers are reorganized and strengthened, restoring elasticity and resilience. The new tissue, though functional, may differ from the original. Scar tissue often forms, characterized by collagen arranged in parallel bundles, rather than the intricate weave of normal skin. This scar may be less flexible, less sensitive, and without hair or sweat glands. Yet it serves its purpose, closing the breach and restoring the barrier. In some cases, scarring may be minimal, particularly in children, while in others, it may be pronounced. Regardless, the process reflects the body's determination to repair, even if the repair is not identical to the original. The capacity for healing varies with depth and severity of injury. Superficial wounds that involve only the epidermis heal quickly and often without trace, as new keratinocytes migrate from the basal layer. Partial thickness wounds that extend into the dermis take longer, requiring more extensive repair of connective tissue and vessels. Full thickness wounds that destroy the entire skin require the most complex healing, sometimes necessitating medical intervention, such as grafting. Burns, in particular, illustrate the limits of healing. For when the dermal structures are destroyed, regeneration becomes difficult, and scarring is more likely. Yet even in such cases, the integumentary system demonstrates resilience, closing wounds and restoring function as much as possible. Healing is influenced by many factors, Age is a significant one, with younger individuals healing more quickly due to more active cell division and robust circulation. Nutrition plays a critical role, for proteins, vitamins, and minerals are essential to collagen synthesis, immune response, and cellular renewal. Vitamin C, for example, is necessary for collagen formation, while zinc supports enzyme activity and healing. Circulatory health is vital, as adequate blood flow delivers oxygen and nutrients to the wound. Conditions such as diabetes, which impair circulation and immune function, can significantly slow healing. Stress, infection, and repeated trauma can also interfere, reminding us that healing is not automatic but requires balance and support. The integumentary system's capacity for repair extends beyond simple wounds. Hair and nails, too, demonstrate renewal after damage. Nails, though slow to grow, can regenerate from the matrix if it remains intact. Hair, if the follicle is not destroyed, can regrow after shedding or injury. Even glands, in some cases, can recover their function. This regenerative ability is not unlimited, but it reflects a fundamental characteristic of the integumentary system: its design for renewal, its readiness to restore itself against the wear of life. Healing is not only physical but also symbolic. The scar that remains after a wound is both reminder and testimony, a record of injury and a proof of survival. The integumentary system does not erase the past but incorporates it into its fabric, carrying the memory of harm even as it restores function. These marks, whether faint or bold, are part of the story the skin tells, the story of endurance and repair. To reflect upon healing in the integumentary system is to recognize resilience in its purest form. The skin, hair, and nails are exposed, vulnerable, and constantly challenged. They renew and recover with tireless persistence. They demonstrate the body's ability to respond to injury not with despair but with action, not with weakness but with strength. Healing is a rhythm, a cycle of clotting, cleansing, rebuilding, and strengthening, repeated endlessly across the span of life. As this calm journey nears its conclusion, the next reflection will turn to a broader view: the integumentary system as a whole, its unity, its symbolism, and its place within the larger design of the body. For now, healing and repair stand as a reminder of life's resilience, of the body's quiet determination to restore itself, and of the integumentary system's role as both protector and restorer, enduring and renewing with every breath of existence. 20. The unity and symbolism of the integumentary system. To come to the end of this calm journey through the integumentary system is to see it not as a collection of separate parts, but as a unified whole, an organ system that both protects and expresses, that both guards and communicates, that both records and renews. The skin, hair, nails, and glands together form a living tapestry that surrounds the body in a seamless covering, one that is both practical and symbolic. It is the interface between the inner and outer worlds, the surface where life meets environment, and the visible record of our passage through time. To reflect upon its unity is to recognize how it embodies resilience, identity, and continuity, serving quietly yet faithfully in ways that are both obvious and profound. The integumentary system is unified first by its shared material. This structural protein, produced by keratinocytes in the skin, by matrix cells in hair follicles, and by nail-forming cells in the nail matrix, provides strength and durability across all its components. Keratin is the thread that binds the system together, allowing skin to resist abrasion, hair to grow strong and flexible, and nails to remain protective and functional. Though these structures differ in form and purpose, they are united at the molecular level, each expression of keratin serving its role in resilience and protection. This shared foundation reminds us that diversity of function often emerges from unity of design, that one substance can take many forms and yet remain constant in essence. The unity of the integumentary system is also expressed in its functions, which overlap and reinforce one another. The skin provides a barrier, but hair adds further protection by shielding sensitive areas, and nails defend the fingertips and toes. Sweat glands regulate temperature, while sebaceous glands preserve moisture, and together they maintain balance. Pigmentation shields against ultraviolet radiation, while sensory receptors in the skin and hair alert the body to contact and danger. Healing processes repair not only the skin but also the appendages, ensuring continuity. These functions are not isolated but interconnected, each part supporting the whole, each adaptation contributing to survival. The integumentary system is a network, not a collection, a harmony of structures working together in silence. Symbolically, the integumentary system carries meaning beyond biology. It is the most visible of all organ systems, the part of the body that others see first, the surface upon which identity is written. The color of the skin, shaped by melanin, reflects ancestry and adaptation to sunlight. The texture of the hair, whether fine or coarse, straight or curled, carries traces of heritage. The nails, though small, reflect health and care. These features become markers of individuality, of family, of culture. They remind us that the integumentary system is not only functional but also expressive, shaping how we see ourselves and how we are seen by others. The integumentary system is also a storyteller. It records the events of life, from the scars of childhood, falls to the lines, etched by years of expression. It bears freckles from days in the sun and stretch marks from growth or change. It shows the effects of nourishment, stress, illness, and healing. Each mark, each line, each variation is a trace of the life lived within. Unlike internal organs, which remain hidden, the integumentary system is both functional and narrative, both protective and expressive. It is at once shield and diary, both silent guardian and visible witness. Culturally, the skin and its appendages have carried meaning across time. In ancient traditions, markings upon the skin, whether paint, tattoo, or scarification, were symbols of belonging, belief, or passage. Hair has been styled, cut, or grown long as a signal of identity, status, or devotion. Nails, too, have been shaped and adorned, transformed into expressions of beauty or discipline. Across societies, the integumentary system has been a canvas for meaning, a surface where biology meets culture, where the body becomes an expression of thought and spirit. Its unity lies not only in its biology, but in its role as a bridge between the physical and the symbolic. The integumentary system also symbolizes resilience. It is the first to meet the world's challenges and the first to recover from harm. It withstands friction, pressure, and sunlight. It heals after cuts, regenerates after burns, and recovers after infection. Though it shows age, it continues to serve, adapting to each stage of life. The very marks of aging, wrinkles, lines, spots, are themselves symbols of endurance, reminders that life is lived in time and written upon the skin. The integumentary system, then, is not only a biological shield, but also a symbol of perseverance, of the ability to withstand and to continue. Unity is also seen in the way the integumentary system connects with the other systems of the body. It does not act alone, but collaborates with the nervous system in sensation, with the circulatory system in temperature regulation, with the immune system in defense, with the skeletal system in vitamin D synthesis, with the endocrine system in hormonal responses. This interconnection reflects a broader truth. No system in the body is separate. No organ stands alone. The integumentary system is both distinct and inseparable, unique in form yet woven into the whole fabric of life. Its unity lies not only within itself but also in its partnership with the body entire. To reflect upon the integumentary system as a whole is to see it as a mirror of the human condition. It is surface yet depth, protection yet vulnerability, barrier yet connection. It shields us from the environment, yet it allows us to feel the environment. It separates us from the world, yet it unites us with the world through sunlight, sensation, and contact. It conceals, yet it reveals. It is both constant and changing, both fragile and strong. Its unity is the unity of paradox, a system that holds opposites together in harmony, serving as both line of defense and instrument of connection. The symbolism of the integumentary system extends further into its role in identity and individuality. No two people share the exact same fingerprints, those delicate ridges formed by the dermis and epidermis, unique patterns that persist unchanged through life. This uniqueness, found even in the smallest details of the skin, reflects the individuality of each person. Yet, despite this individuality, the integumentary system is shared by all, a universal feature of humanity. Its unity is thus both personal and collective, reminding us that while each skin is unique, the functions and purposes of skin are shared across all people. As this calm lecture draws to its close, the integumentary system can be appreciated in its full unity and symbolism. It is not only the body's largest organ, but also its most visible and expressive. It protects, it regulates, it senses, it heals, it records the passage of life, it reflects identity, it connects body to world. It is keratin and melanin, collagen and glands, scars and lines, resilience and renewal. It is both shield and storyteller, both barrier. To contemplate the integumentary system is to contemplate life itself, the need for protection, the inevitability of change, the beauty of individuality, the strength of resilience, and the unity of body and environment. It is a system that sustains us silently, faithfully, and without demand, carrying the marks of time and the traces of experience. Its unity is its power, its symbolism is its meaning, and its quiet service is its gift. With this reflection, the journey through the integumentary system is complete, from the surface to the depths, from the newborn's first touch to the elder's weathered skin. The integumentary system endures as a guardian, a communicator, and a symbol of life itself, whole, resilient, and beautifully human.